Hello, everybody, and welcome to SkyTour LiveStream. This is Mark D'Antonio, and it is April 24th, 2019. I am here with Daryl Mason. Daryl, how are you?
I'm good, thank you, Mark. How are you?
Hey,
Hello, everybody.
sure thing, man. I'm fine too. You know, I'm glad that you're doing well. I know that it's an interesting evening because it's very clear here, but it's supposed to get cloudy after midnight. So we're gonna try and race to beat the band here. This opening graphic that you see here, this is actually Alpha Centauri's third star in the triple star system. This is Proxima, and way up there in the corner, right there, those two little stars you see right there, that's Alpha Centauri A and B. They're a binary pair, and then Proxima right here has a planet around it, and this planet may or may not look like this. We don't know. We don't even know if it has an atmosphere at this point. But boy, oh boy, it looks like this is a really nice rendering. So you see the two stars there, and you see Proxima here, which dominates the sky. And on Proxima B, which is the planet circling Alpha Centauri. So actually, that's a pretty cool thing. This star actually orbits both of those stars in a very, very long orbit. It goes around both of them. And really neat. So I just thought that would be kind of a cool thing to put up there as a little introductory scene. But now let's go over to the rest of the world where we are. This is our SkyTour Livestream main view, and for those who are just joining us for the first time, and I know that many of you have been here before. I know there's only a few people watching right now, but the numbers will climb, and if they review it and listen, they'll hear it. This is the telescope control system over here. This is me, hello, and the dome ops. We're running on blue light tonight. And then up here is the telescope camera controls, and then the dome cams right here. This bottom one is riding on the telescope. You can see the barrel of the telescope at the bottom there. And this is the other camera looking up at the telescope from below. Anyway, I want to just welcome those of you that have come in early. Thank you very much, David Schmidt, Bonnie Stanley, and of course, Charles Smar. Thanks for coming in. And we're going to be zipping through the Leo galaxies and having some fun with those tonight. And maybe, if the weather holds out and my voice holds out, we'll head into the early summer sky and check out some of the objects in the summer sky. I gave the telescope a little bit of an overhaul, so things are looking nice out there. I had it up and running for a couple hours so far just to try and get this system all up and running and have it keep going. So let's go for a little tour, shall we? This star here, if you want to know what it is, well, you just have to jump over to our planetarium that we always use here at SkyTour Livestream, and we're actually seeing a star that's this one here because it drifted. It's called Aldebaran, and this is in the constellation of, well, you won't know, right, until I throw up the constellations. And now you see, it's Leo the Lion right there. Well, how do I know it's Leo the Lion? Because we can bring up our mythology imagery, and you can see Leo the Lion right here. Very cool. So anyway, well, what kind of things do we see in the constellation Leo? Well, unless we bring them up, we won't see them. But here we do see them, and these are many galaxies that are in Leo. There's a ton of galaxies. And we tend to go to the likely suspects each time we look in Leo, but we're going to try and look at some others as well tonight. In any case, I just want to give Daryl an opportunity to tell us what he thinks we might want to look at tonight, because after all, he has some really good ideas too. So go ahead, Daryl. Tell us what you'd like to see.
Golly, thank you. Well, it's that time of year, and it's the usual suspects. I mean, as you can see right there, it's Galaxy season. Uh, uh, Trolling from Canis Venatici, the hunting dogs below the Big Dipper's handle, down through Coma Berenices to the upper left of the Lion's Tail, and through Leo himself and down into Virgo. I don't think you can beat that.
That's
It's
right.
that time of year. It's
Yeah,
Galaxy season, people.
that's right. When you look in Virgo, for instance, check this out. Inside Virgo, we have all of these many galaxies, and there's a reason for them to all be clustered together, and it's because this is part of what's called the Virgo supercluster there are many, many galaxies in here. So many, in fact, that one particular galaxy that we looked at the other night, called M87, is a galaxy that actually has that black hole that was imaged recently. I talked about that when I was in Arkansas a couple weeks ago, or actually, well, let's see, how long ago was that? Geez, I lose track of time already. Had to be over a week ago, right? So it was really kind of cool because we ended up down there, and I was talking about how this black hole actually works. And it's weird because no matter what angle you look at it from, you'll still see that round shape around it, the round light disk. People are calling the accretion disk. We're not looking down on top of it. We're actually seeing the warped light that's actually from even behind the black hole. That's going as the light leaves that disk behind the black hole. It's bent. It's following space, which is warped, and it follows that curved space, and it always comes over the top of the black hole. So you'll always see this disk of light. It's really strange. It's just the way it works. Black holes are strange. I'm gonna come up with a better descriptor of that too, moving forward at some point.
May I say, I did eventually see I believe they mentioned 4 different images of the black hole at the time of the original press conference.
Yeah.
I did eventually see the 4 different images. Might have been on YouTube, I forget. But they gave a really good explanation of it all, and as part of the functioning of the very long baseline interferometry, as the Earth rotated, well, they showed the image change as like you went between pairs of telescopes or something of the sort.
Mm-hmm.
And it was really interesting how different the different virtual apparitions, whatever, showed what the eventual final image became.
Yeah.
And they were quite different images.
That's true.
They announced at some point they sort of blurred the image to give like a typical radio astronomy composite. But seeing from one image to the other, they look very different from each other. The bright spots in the accretion disk were in different places and all sorts of stuff.
Yeah.
I just thought it was fascinating.
I think so, and that very long baseline interferometry that they use, basically that's a fancy term for saying that they just were able to take the imagery and basically add it all together over time to come up with a synthesized final image.
Sure.
And so when they add this all together, it's sort of like, I don't know, stacking at a much higher level. Image stacking, kind of, sort of. And it's so interesting the way they do it, because I think that it's probably the first time that we use the entire Earth as the baseline, to get a literally telescope, the diameter of the Earth, which is 8,000 miles, across. So that was really fascinating. I thought that was just spectacular.
And just wait until they get some satellites in orbit involved.
Oh, I know,
To increase that baseline, by a factor of 10 or 100. That's going to be amazing.
Yeah, because then we'll be able to use Earth's orbit, as the baseline. Can you imagine that? A telescope the diameter of the Earth's orbit?
Right.
Wow. 15 seconds at 6,400 here at a location that looks like blank space. Let's see what we get. And I want to say hello to Marianne Robb, who just joined us. James Dugan from Down Under. Hey, James, how are you? David Schmidt is, of course, from Bangkok. And Charles Smar is here as well. And yeah, you tell people to hit that like button. That's cool. I'm glad you guys are gonna do that for me. And okay, so we've got a couple of galaxies in here, and they're a little low because I have to bring them up into the view a little bit more. So I shall do that. I love playing with galaxies. They're so much fun. Okay, so bring up our telescope control system, and let's bring this all up a little bit. Here we go. All right.
Oh my God, I'm missing Forged in Fire. You don't know what the sacrifices I make here sometimes.
Uh-oh, really?
Yeah, if I have a TV night, it's Wednesday night. I love watching Forged in Fire.
Oh boy.
I
Uh,
used to be a bladesmith, among other things.
really?
Oh yeah, I'll have to show you some
How,
pictures sometime.
how how do you used to be? How do you used to be a bladesmith rather than I mean, do you ever not? Are you ever not a bladesmith?
Well, I don't have access to a machine shop or a forge or anything anymore. I
Oh.
retired 3 years ago,
Oh, I
so
see.
I'm an ex now.
You're an ex. Former. There's no ex. Former.
Well, there you go.
That's right.
Anyway, I'd rather be here anyway. I'll catch it on the reruns.
Well, as long as you're recording it.
Well, actually, no, I'm not.
Oh, well,
But I'll catch it on reruns.
I'm
No
sure I
worries.
can show you how to get it. It's easy to
Show us
get
something
online.
cool, Mark. Yeah, show us something cool, Mark.
Okay, how about that? So you can see the noise reduction stuff is kicking in here, and I'm noticing a little bit of a tint, which tells me that down here, I think we might be impinging a little bit on the dome, which is why we're getting this weird shading here. But I think this will be okay for now. Interesting. Okay, so let me come down here and over. I'm going to just shut down some things here, and I'm going to go now over to get a close-up here. Alright, there we go. Let me want to fix that a little bit. Oh, I see what I did. Okay, just a minute. 1 second. So we got this, and we got that, and then that's what I wanted. Okay, so now we're going to come in here, and we're going to go in our filters, and we're going to take and bring back just a little bit of the detail here. Alright, let's see what that does for us. Okay, so we can see this beautiful pinwheel of stars here. This galaxy is quite far away, actually. And how far away, you ask? Well, let me go tell you. Let's go here and look. Okay. Oh, no, where'd it go? Oh, we're here. We're looking at M95 right here. And that is a galaxy that is 32 million light years away. 32 million light years away. So you're seeing it 32 million years ago. All right. Now, what's interesting about this galaxy is that even though we see it 32 million years ago, that's telling you that the light left it that far back in time. So everything we see in the sky here, everything, we're seeing it at a past time. So this one star, for instance, this star here, okay, this star has a distance of 657 light years. Okay, this star, known as, it's in the Hipparchus catalog, HIP 51892, or the Smithsonian Astrophysical Observatory catalog 99198, or the Henry Draper catalog 91785. This star is actually a star that's over 650 years in the past to our eye right here. And it's a K-type star, so it's orange. You see, this is what's going on. This is what we see when we look in the sky. Very interesting. Very, very interesting. So, again, it's all about history and looking back in time. So let's move up just a little bit now and go and check out these guys right here. All right? I think this would be cool. And we're going to do that right now. All right, and we're moving ourselves up. You can see the telescope is moving. And let's just bring back everything. Bring up our controls. Wait for them to stop. And then we'll be able to do our imaging. Okay, and then just a little jog. Now we'll do 20 seconds at 10,000 just to see what we get here. Hello, Pam Wetzel. Nice to see you. And we are going to be looking at some cosmic treasures. It's very kind of you to say that. I think that the sky is beautiful, and These are treasures that you won't see without a telescope. And the way we do at SkyTour LiveStream, we show you these treasures in mere seconds, which is different from the way it normally is. Typically, we have to spend a lot of time, taking photos and so forth. But as you can see, we're seeing these beautiful treasures right here. These galaxies, these galactic gems. They're tens of millions of light years away. I'm going to bring these over just a little more just to get us a little bit closer into there. I can see now the trend for where it's going to go. So we're going to be trending eastward now. Okay, so this should be good. All right, and now I believe we can take another 20-second photo, and I'm going to go to 12,500 ASA, or 12,800, sorry, the sensitivity. And then we'll see what we get, because this is a better way to do this. And it might be harder to see me down here. I'm actually running in blue light tonight. It's actually called CIC. That's the setting I have on my lighting in here right now. But I can always change it. If you really want it to be red, we can go to red just like this. Okay.
I think the blue is cool. Looks like you're inside the lava lamp.
That's right. That's true. There we go. Look at that. So there we got our beautiful galactic view here. And now if we do a little processing. And that's the nice thing about what we do here. Hey, Justin. That's the nice thing that we do here. We actually like to do some instant processing on the fly so you can see details that might be hard to see. But these three galaxies are just beautiful standouts,
Leo has so much neat stuff to look at. You got M95 and 96, and the little trio above them under Leo's chest, and then if you go under Leo's belly, you've got M65 and M66 and the Hamburger Galaxy.
That's correct.
Making the Leo triplet.
That's right. And where Daryl's talking about is over here. The Leo triplet that he was just mentioning. There's this guy right here, this one here, and then this one right here. So we got this one and this one. And this is, these three together make the Leo triplet.
I'm sorry, don't let me take you away from what you were doing.
No, that's fine. I just want to put a context for the folks who are watching. I think that made a lot of sense.
Super.
Yep. So let's go back to our view here. And let's do this. Let's take a longer exposure, 16,000 for 20 seconds on this. And that should be good. Yes, indeed. And then we will automatically see a beautiful image to show up for us in just a moment. Didn't take long. You can see the noise getting processed out over here. That's one of the things that I like to do, is take that noise and get rid of it.
Something tells me Marianne used to dance disco. Just kidding, Marianne.
That's so funny. Actually, I think she likes the red and blue lights because she drives a police car.
Oh my God, you're absolutely right. I forgot. I'm sorry, Marianne. Did you disco though, Marianne?
Yeah, tell him, Marianne. Tell him whether you discoed or not. I don't know the answer to that question.
I'm being bad tonight. I'm sorry.
Oh, that's hardly bad. That's fine. Okay, so yeah, look at that. So we got this beautiful set of galaxies right here. And these three now, in terms of their distance, let's just check that out. Okay, so we were looking at these three right here. I think it was it M105, NGC 3384, and NGC 3389, correct?
Looks like.
So we're looking at 26 million light years away for the left one. M105 is 31 million light years away. And then down below that one that we looked at near the bottom there, that was 80 million light years away. And that's why it was a little bit fainter, okay, when we go back to our image, okay? Okay.
That really gives you perspective on things.
Yeah, you can see this one, these two are closer to us. That one's further away. They look like they're right near each other, but that's much further away. That's 80 million light years away. And these are only in their 30s, you know? So you can see that that's a long, long distance away. That's incredible, you know? Disco dog. Oh, yeah, I remember that MTX. Disco duck. Holy cow. I can't believe people actually like that song, but they did. I used to think it was funny, too.
Death to disco. That's always been my feeling about the matter.
Yeah.
I did have a pair of platform shoes once, though.
So did I. Because that was sort of the style. My mother bought them for me. I wasn't, kid in school, so.
Yeah. Oh, hey, platform shoes and a bow tie, man. That knocked the girls.
If you say so. Man, this is beautiful.
I'm being bad tonight. I'm sorry.
You're not being bad.
Being naughty.
Not at all.
We need Amanda here. It'd be perfect.
Yeah. If Amanda was around, I tried to find her earlier. You still see the shared screen, right, Daryl?
Yes, I do.
Okay. And it's not frozen, right? You see me moving around here?
Yeah, I see your cursor moving.
Okay, good. Because it says, but did you lose the sound?
No, I hear you just fine.
Oh, the music.
I don't hear the music.
Oh, okay.
Now,
That's all right. That's what it was. Okay, so let me just stop sharing and redo the sharing.
We're good.
Because I just want to make sure that I want you to hear it. So if you folks are wondering what's going on, Daryl being on live with me, I'm actually having him listen in on everything that's going on here, including the music, so that he will know where things are. And of course, he's seeing my screen live so that he can react at the same time. Otherwise, he has to wait the 30 seconds that everybody has to wait for these things, which is kind of ridiculous.
We're good.
Yeah, I think we are.
Yeah, I hear the music now, and I see your cursor moving live, I think.
Good, yeah, and that's live.
If you could get rid of that ugly mug of the guy in the blue hat, I think it'd be perfect.
Oh, okay. Well, that's only something you see. Nobody else sees that. There we go.
Good.
Very good.
Used to be so pretty.
Oh man, you're hilarious. Okay, let's just go back now to this. All right, and let's bring back our screen. And actually, I want to go here. I want to go not there. I want to go to here because I would like us to travel to another location. And we're just zipping through Leo here. There's many little galaxies right here. Let's check these out and see what we have. So we're going to go there. And you'll notice the telescope moving only a very slight amount, if you can see it move at all. Oh, yeah, there you go. Yeah, you can see that. Telescope moves just a little bit. Yep.
Does it start with an M?
What's that?
Whatever we're going to look at next.
Oh, is it a measure?
Yeah.
I don't believe so.
Oh, okay.
No, I think we're just I'm just gonna take us a little bit eastward, and then one more little bit, and jog it back a little, and now we'll take a picture. Let's do 15 seconds. We'll do 15 seconds here at 16,000 ISO sensitivity. All right, and then this will take us to our next set of galaxies. Oh, hopefully. I mean, these are small galaxies, so we'll see if we can see them. We don't have to worry about the moon for a few hours, but I'm not sure how long we'll go, but we'll see how far we can go. Hey, Rock, what's going on? All right, so let's take that. This picture's underway. Or it was not underway, apparently. Now it's underway. Okay, sorry about that. All right. Okay, so let's watch this come in. We should be on the downside of the 20 seconds now. There it comes. Wow, that's pretty. Look at that. That's beautiful. Look, there's a beautiful galaxy right there. Very, very nice. That's the whole view right there. And we got a very faint object over here. Got one there, just like as promised, and then that bright star. And when we're in our planetarium view, you could see that. You could see that we had these two galaxies in here, and then there was a bright star. Actually, we should actually be able to look for these two stars. So we have a galaxy right here. I wonder if we got that. Let's find out, shall we? Let's see. Okay, there's the stars, and I can't tell, Daryl. I can't tell if there's supposed to be a tiny little galaxy in here. I know we got that one. That's beautiful, and then that one.
I think I see a dim little fuzzy, maybe in the middle of that curved row of stars over there on the right-hand side.
Over here? Or over here?
Yeah, right about in the middle.
Or right in here?
To the right. One more star to the right.
Oh, right there maybe?
No, to the lower right of that.
Oh, okay. Maybe right here?
Just above that little dim fuzzy star there.
That right there? Above
yeah,
the top of the hand?
Real close to that, yeah.
I see one right above the top of the hand here, too.
Okay.
Yeah, actually, what am I doing now? Why don't I just zoom in?
Actually, I thought I saw another one close to that one. There's a little dim one up there in the upper right corner.
Yeah, that's the one. That's the one I was just pointing to.
Yeah, I think I saw 3 different galaxies there.
Yeah, there are plenty. There's plenty of galaxies here.
Oh yeah.
Yeah, and that's the thing about. And this isn't even Virgo. This is Leo, and Virgo has many more. You know. But look at it. These are all island universes of stars. All island universes. These things are just amazing. I just find it so utterly amazing that there's so many galaxies in the universe. We've got probably 2 trillion galaxies. And in our own galaxy, modestly with maybe 100 billion stars in the low end, with a wild estimate of possibly 400 billion in the high end, we might have up to between 10 and 40 billion Earth-like planets just in our galaxy. And if there's 2 trillion other galaxies, let's let those numbers work on you for a while. 2 trillion other galaxies, and in 100 billion stars, we might have 10 billion Earth-like planets. Basically, there's more planets than there are stars in the galaxies that we see, by the way. More planets than there are stars. That is incredible. So I'm pretty excited about the fact that we should be able to see within our lifetimes, probably be able to catch a lot of data that would tell us whether there's life elsewhere. You know, Carl Sagan, once did he asked for the crew of the Galileo probe mission that was they're running the probe down at JPL, I believe. He asked that they turn the Galileo probe back toward the Earth so they could look at the Earth and see what a vegetation-laden planet looks like from that probe. And the presence of mind he had for doing that was that of a science genius, because basically what he set up was the ability to gather data on what a planet looks like when it has desert, when it has rainforests, when it has oceans. What does the reflective qualities of the light look like for these different types of terrain? And they built a database, and it's called Reflectance, Reflectance, ANCE, Reflectance. And they were reflectance indexes, basically, that they were capturing of this material that was reflecting back into space from the planet's surface, depending on the kind of terrain it was. And they built a database that said basically, hey, that is what desert looks like. That is what a rainforest looks like. This is what oceans look like. And because of that, we now have data to help us when the James Webb Telescope looks at the distant atmosphere of planets and their reflected light. And we can then figure out whether the planet may have plants on it that are using photosynthesis to convert sunlight into energy for life. It'll be a very interesting, it is a very interesting possibility. I just think it's the best thing in the world. I'm really excited about this. This is probably the one of the literally foremost discoveries we could make would be life elsewhere, right? I mean, it'd be very interesting to find out that there's life here. That's a joke there, but still.
Intelligent life.
Yeah.
Yeah.
Scotty, beam us up. There's no intelligent life here. Aye, Captain. Right away, sir.
There you go.
Yeah, now off we go. So I think that it would be kind of interesting to see whether there's intelligent life elsewhere or just plain old life. We're going to probably find life in our own solar system. For sure.
Mark,
yeah.
Could you do something, please? Back out a little bit in Stellarium. Don't move your telescope, but back out so... can we possibly see from Ursa Major down toward Leo and Virgo?
Yep.
Can you open up that much?
Yep.
All right, there's Ursa Major on his back right there.
Mm-hmm. There's the Big Dipper.
Folks, I said before, this time of year, if you go from Ursa Major, let's say maybe at M81 and M82, Baudet's Galaxy and the Cigar Galaxy.
That's these guys, yep.
And if you go then just kind of in a broad line there, you can see some galaxies there, that triangle off the tail of the bear. That's Canis Venatici right there, the hunting dogs. And if you keep going from this point of view toward Leo and Virgo and Coma Berenice, of the 1,000 brightest galaxies in the sky, you can see 3/4 of them in a broad band there.
Yeah.
From Ursa Major through Canis Venatici and Coma Berenices, and then down into Leo and Virgo. You can see 3/4 of the 1,000 brightest galaxies in the sky in a band moving across the sky right there.
That's it. That's right.
And that's why it's galaxies.
That's
hey,
right.
There's a sombrero.
I know.
Maybe later.
Yeah, I'm not sure if we're in the right place to see that yet.
Okay, cool. It's early yet.
Yeah, I might be able to. Sombrero's just beautiful.
It is. There are some must-see things out there in that band of galaxies, and that's one of them. It's right there. You see Spica right now, and it's just to the right of Spica. Maybe we can see that later.
Yeah.
Then up above that, you have the Virgo cluster itself up toward Virgo's head.
Yep.
You're just starting to get a hint of right there right now. I mean, there are just endless galaxies up in that part of the sky.
Yeah, and that's again the Virgo supercluster that we are all moving toward as a whole. All of our galaxies that were in our local group are moving in that direction. All toward M87, that black hole, that black hole laden galaxy. Actually, every one of these galaxies probably has a black hole at their center. That may be what is a fundamental tenet of the universe, is that there are supermassive black holes at the center of most galaxies. That's kind of what we believe anyway now.
Mark, can I ask you something?
Yep.
I sent you something recently, I think, after the black hole image came out. There's M87 right there.
That's right.
That they sort of, the scientists, or I don't know if they were just splitting hairs or what, but they seem to distinguish between calling what we interpreted as the event horizon. They called it a shadow.
Yeah.
Would you care to discourse on that at all?
I think
Or is it ultimately the same thing still?
It's sort of the same thing. It's kind of tough because we're seeing a shadow because we can't actually see the event horizon itself, because the event horizon is where the space is so warped that the light cannot circulate out of it. So we're actually seeing the place where the light is not.
Well said.
So that is a shadow, basically. And it's not semantics. They're actually trying to make a very specific distinction here between these, the event horizon and the shadow of the event horizon. If you notice the way it looked, okay, it wasn't just a sharp delineated area. That's, of course, because of distance, of course, the resolution of the telescope, naturally. And, of course, because in reality, we wouldn't see it as a sharp distinction either. It would be only something that we could pick up through the absence of light. So, basically, we're seeing where the event horizon is. And they're basically just trying to say, we cannot see the event horizon. And we can't actually see the event horizon, so don't think that you can. That's not what we're looking for. We're not looking at the event horizon. There's no event horizon to be had here. It's there, but its presence is only given away by the lack of light, the absence of light. So
I understand, and I think that's a fascinating distinction. Not that it makes much difference in the end, but well said. Thank you.
No, you're welcome. I think let's see. I'm over here. We'll try it. Let's go see if we can go to that galaxy anyway. See if we can get to it. All right, and let's just watch the cameras in the dome and see if they. Well, that wasn't it. Get rid of that.
I do hope they show Sagittarius A star sometime, because I bet you dollars to donuts they have a good image of it as well.
You think so?
Oh yeah.
No, maybe.
Well, I know they were talking about it as another target. I wouldn't be a bit surprised. I have to guess that M87 was a more impressive image, but hey, I want to see what our black hole looks like.
Oh, well, we know what ours looks like.
Yeah, I've seen the videos and the animations of it and all that. The stars orbiting.
Yeah, that wasn't an animation.
Oh, I know.
Yeah.
Well, there were animations out there, but yes, there was actual video.
Oh yeah.
Also.
Oh yeah. In fact, let me see if I can show you that, because I used that in my talk, and I thought that was just beautiful. It was a very interesting image. So let's go see. Let's go here. Okay, this is Sagittarius A, and that's it right there. That's it right there in the center. And look at the stars, the way they're going around. Okay,
wow.
This is absolutely incredible.
It is.
Okay, if you notice how this works. Okay, the stars now. Hey, Dude W and Patrick Webb. Hi there. Welcome to SkyTour LiveStream. We're actually watching the stars orbiting the black hole at the center of our own galaxy. This was an image that took 10 years to make. All right, and so to that end, this was a very, very well made video to illustrate how stars move in our own galaxies, around our own galaxy's black hole. So let me just bring this up here. So there you go. This is the full size view of it. Okay, so these are all stars. These are not computer simulations. Okay, watch this star coming in right here. Boom, right around there. Now that they were tracking the path. Notice that this is the date. Okay, from about 1995 to or 92 rather. Okay, and now watch. Okay, as this star comes in, watch this. Wham. Okay.
Yep.
So
That's like go-karts doing hot laps.
right, and that's actually a very cool way to visualize our own black hole. You can see the stars orbiting around something we can't see. Isn't that crazy? That's absolutely cool. Yeah. So that's just that's actually 12 years worth of data we're looking at there. It took 12 years to see the stars move this much. Can you imagine if you watched it over a million years?
Up there at the top right.
Yeah, light days.
10 light days. So that's pretty close up.
Yeah.
I have a beautiful book I got years ago for Christmas about Sagittarius A star and the stars you're seeing now orbiting the black hole. They were color images, doubtless artificially treated, but great book. I forget who the author was. It was an Italian astronomer. It was called The Black Hole at the Center of the Milky Way or something like that. The book was.
Yeah.
A beautiful book. Beautiful images.
Wow. Yeah, I mean
that's too much. I mean, that's Star Trek, center of the galaxy kind of stuff.
I know, right?
There. Yeah.
It sure is. Well, anyway, folks, that's the center of our galaxy right there. That's the imagery of the center of our galaxy. And if you want to see it again later, let me know, and we will check it out. Right now, I'm going to take a 15-second exposure of this region of the sky here, where I expect to see M87, along with, that is to say, the galaxy that made news recently for its black hole that they imaged in the center. And we should see that. Oh, no, it won't. It's right there, but we can't see it because of the fact that the dome is in the way. So I have to rotate the dome a little bit. And for those of you wondering, what's that?
Is it early yet?
It's actually in pretty good location. It's not that early. Okay, so if we go to the planetarium here and check it out, we can see that if we zoom out a little bit, you can see that we actually have it. It's just in the southeast. It's not way out here in the east, where it's still rising. It's actually pretty good. So I just have to rotate the dome a little bit. And for those wondering why I haven't automated the dome yet, the reason is because the goal is to eventually have a roll-off roof observatory when this telescope gets to Arizona. Right now in Connecticut, it's not worth having a roll-off roof, but it would be in Arizona, and that's exactly what I'm going to do there. And then I only need one motor, and the roof goes right off the building, and then it rolls back on. Because I'm doing everything automatically. I want to say hi to Ashley Hartman. Thank you for coming. Welcome. It's great to see you here. I always try to personally welcome each and every person when they join and come on board. And I will do that when we have many, many more people in the chat too, to the point where my voice will get hoarse just saying hello. But Daryl, what I'm going to do is I'm going to leave this zoomed out. And on the planetarium side, we keep on looking at Leo here while I go move the observatory dome a little bit, okay?
Very good. I'll try to keep from boring them to death.
I'm sure you will.
I'll try to bore them to death.
Or you can. All right. I'll be right back. Be right back, folks.
Put the planetarium view up. I'll talk about it.
It is. It's up. You see? Do you see it?
Oh, very good. Yes. Okay.
Oh, okay.
Sorry,
Okay.
I was looking at the wrong screen.
That's okay. All right. I'll be right back.
Hi, everybody. Hello, Stacy. Welcome, everyone. Hello, Dew. Hello, James. The usual suspects. We're looking at Leo right there while Mark is gone. You see there on the right that kind of backward question mark looking thing, and Regulus at the bottom. That's called the sickle of Leo. You know, a sickle like what they used to go out and harvest wheat with. Looks like a big backward question mark, and Regulus is the period at the bottom. Regulus is variously interpreted as the heart of the lion. Sometimes it's like the lion's foot. If you look over to the right there, to the left, Denebola, that's the lion's tail. Hopefully you can make out the shape of the lion there. It's like he might be standing, he might be laying on his belly like lions do sometimes, but I think you can make out the figure of the lion. And then over where Mark's pointer is at, the little flashing square, that's up in the head of Virgo near a star called Vendemiatrix. Don't know how to say it, Vendemiatrix. Near or in the head of Virgo, the Virgin, and that's right where the center of the Virgo supercluster of galaxies is. He was looking at M87 and imaging it. He went to turn the dome to get a better look at it. M86 is a huge elliptical galaxy in the very center of the Virgo supercluster. Everything else is either orbiting it or, like us in the local group of galaxies, we're falling right toward M87 in the Virgo cluster. That's the direction we're moving as a group with our other nearby galaxies in space, falling toward M87 in the Virgo cluster. Golly, what else? Another constellation called Coma Berenices is right up behind all that lettering, sort of between and above Virgo and Leo there. Coma Berenices is Bernice's hair. That's a constellation. Berenice was quite a gal, I guess. She sacrificed her hair as an offering to the gods. Tons of cool galaxies up in there also. Maybe we'll get to see some tonight. One of my favorites is NGC 4565. Sometimes I think they call it the spindle galaxy. It's looking at us almost edge on, and you can see the dark lane running through the center of it. If you've seen the hamburger galaxy below Leo before, 4565 looks kind of like a finer resolution version of the hamburger, or like it's been squashed flatter.
Yep.
Mark's back.
Well, yeah, did you see my screen moving?
I did, yes.
Okay. I'm going to focus on the one shot we're already on with the M87. Let's try and grab that again. I think it's going to work this time because I managed to take care of the dome and get it where it needs to be. And I do know I've got to move the telescope over a little bit, so we're going to head eastward. That's the only thing I haven't done. I haven't realigned yet. I was going to realign, but I haven't. And that's just my fault. I haven't done it yet. So 15.
Bad astronomer.
I know, bad astronomer. Bad. Psh, bad. Psh. Yes. And DW is checking to see if Amanda's over in Bill's. But she also knew that we were streaming. I told her to join us to stream, and she said she would. And there we go. So now we have M87 back. Oh, yes, it looks really pretty now. Okay, so this is M87 here. This is that galaxy that everyone was so excited about. Holy cow. Look at that.
And there's the jet.
Talk about clarity. This is rather odd. We've not had this kind of clarity. Actually, the stars are a little tiniest bit elongated, but they're elongated coincidentally along the line that is where that jet is. That's really cool.
That really is.
It looks very obvious now tonight. First time. It's never been that obvious. But that's okay.
Folks, I hope you can see that, people. That's really cool.
Yeah, this is... I'll show them again here. This, right above the hand, you can see that like kind of a little line right there. You notice there's no other line like it here? That line right there is actually a jet of material shooting out of the black hole in the center of that galaxy.
Uh-huh.
And it goes over 100,000 light years in length. And it actually goes the other direction as well. But this is coming toward us, and it's going into the page basically behind the galaxy, so we can't really see it the other way, which is interesting. And that is coming out of the north pole of the black hole's rotation direction, and the bottom, the south side, the south pole of that rotation direction. Black holes have tremendous magnetic fields. Lots of high energy material is migrating around on the surface where the event horizon is. And that stuff can escape if it's not in the event horizon. And when it does, usually we see it as X-rays and other high intensity radiation, as well as very strong magnetic fields. We noticed black hole regions as well. So, and there's really strange stars too, by the way. Just before you reach the black hole stage, you have to have a certain mass of a star that can collapse down beyond the white dwarf stage, beyond the neutron star stage, to a black hole. And typically those are the three collapse states, okay? And they come from when neutron stars, for instance, are created in supernovae. When a star goes supernovae, what's left as a remnant is usually a rapidly spinning neutron star. Sometimes there's hot spots on the surface of these neutron stars, and they flash at us as they rotate past us, and those are called pulsars. When they were first found, they actually thought that maybe pulsars indicated extraterrestrial intelligence trying to signal us. But it turned out that it wasn't the case. And the pulsars spin like clockwork, very regular. But they do spin down over time. And they will lose their energy and spin down. And that's what happens to pulsars. And the pulsar is the remnant that's left behind after a supernova. And it's a rapidly spinning neutron star. Okay, now, if the neutron star is greater than about 2 solar masses, 2.4, 2.2 I think might be solar masses, then the collapse can continue. And that collapse that could continue would be something that would take the remnant after the supernova to a black hole state. When I was younger, I've told you guys this before, I think, I never actually believed that black holes were possible because they just didn't seem possible to me. But that was my own naivete, okay? And as I got further along in my astronomy, and of course I got a degree in it, but really all that means is that I had a little bit more knowledge to talk about astronomy than maybe a few other people. But the fact of the matter is, as I got further along in astronomy and astrophysics, I realized black holes are quite possible. And I just think that it's really the immensity of the magnetic field and the gravitational field in particular is what causes this issue we hear about with light. Because when people say light has no mass, well, it's true. Light acts as a particle and light acts as a wave. But it's a particle with no mass. So, wait a minute. How come gravity can bend a light? Well, you're missing something in the middle there. And that thing is, gravity warps space. And light just follows space. So if space is curved, the light will follow the curve. It follows the curve. Just like your car follows the rolling hills as it's going down the road. If your car is a light photon and the rolling hills are the result of gravity bending space, well, then you're going to go up and down the hills and follow space the same way. That's how light works, too, in space. So we're actually watching light follow the curvature of space. And right here in this black hole, right here, we actually see that in the image of the black hole. And Pam is asking a question in the chat. I'd like to answer. She says, do you think black holes are a gateway to other parts of the cosmos? Yes, thank you for all the all caps, Pam. That was very nice of you. And that's why Daryl said it. That way I won't miss the questions. So thank you for that. Well, I'll be honest with you. We don't know. I've told the story before. I sat, you guys saw the movie Interstellar. and there was a physicist, astrophysicist named Kip Thorne, who was the consultant. And Kip Thorne came up with a really nice rendering of this black hole, about what it was supposed to look like. And then the Hollywood artists took over to make it look cool. Well, hey, Shep. I sat with Kip years ago for several hours, and he was discussing a conundrum he had with Stephen Hawking, where they were going back and forth on how black holes, Kip said, could effectively give us information, kind of like time travel. So you could like see your ship coming out of the complementary white hole, which is the opposite of the black hole. If such a energy existed, you could show that the ship would be visible coming out of the white hole before you actually entered the black hole. So it's almost like you're looking into the future. Okay. He sent that to Hawking, and Hawking said that's impossible, Kip, and here's why. Then Hawking started to look at Kip's analysis further, and Kip looked at Hawking's analysis, and Kip Thorne said back to Hawking, yes, you're right, Stephen, you can't do it. But then Stephen Hawking wrote back and said, well, actually, Kip, you're right, you can do it. So they swapped positions. And that story I love, because the fact of the matter is, it shows that even the brightest minds on our planet, when it comes to these guys right here, the black holes that are powering the centers of these massive galaxies, we don't actually have all the answers, do we? So, Pam, to answer your question, I don't know if it's a gateway. I don't think so, based on the physics we understand so far. With the understanding we have of physics so far, we would have to say probably not, because you would get what's called spaghettified as soon as you got near the entrance to the black hole, that event horizon, that place where the space gets so warped that the light ends up curving around inside that area and never gets back out. You would actually get stretched out into technically an infinitely small thread, which I think would be pretty gross. Now, in practical terms, your body would just get ripped to shreds, because the gravity on your feet would be a lot stronger if you were falling into the black hole feet first. The gravity on your feet would end up at some point being far stronger than the gravity at your head. So you would get torn. It'd be like the ultimate cosmic rack. It's like the cosmic rack. Remember the rack, the torture rack, where they just stretch people? Well, this would be the cosmic rack. So I hope that answers. Yeah, it is painful. I can imagine it's painful, Pam, but I think it wouldn't last very long. But hopefully that gives you an idea. First of all, the answer is I don't know. And second of all, we couldn't survive knowing the physics we do now so far. Maybe that will change. But right now, I don't know. So we'll see.
Mark, Karen L. Belmont asked a question of you, possibly related to what you just talked about. Is there time in a black hole?
I suspect that time is the same if you are the object moving in the black hole. But if you're watching objects moving within a black hole, it depends what you're looking at. And I think that if you're in the black hole, then looking out of the black hole, everything else may seem... Again, it depends on how fast you're moving. Okay, because the question is, does warpage of space cause time to change? And that would indicate that time is also subject to warpage of space. And so far, I don't believe that's the case. I mean, not directly. We do have time dilation when you move near the speed of light as an object. So if you're an object that's moving near the speed of light, you can't move at the speed of light, or else you are pure energy at that point, and the discussion is a moot point. So I think that means that we would actually end up probably finding that as the object moving in a black hole, we might feel like time is passing normally for us, but outside the black hole, somebody looking in to the black hole, well, they would just see black, okay? So let's say you're above the event horizon, moving above the event horizon. I can't tell you what's going on with time inside the black hole. I can only speculate that we would feel time normally if we were in the black hole. But I don't know if there's any relativistic effect to time based on these immense gravitational fields. Technically, I don't think there is, but who knows? I could be wrong about that.
Can I jump in there?
You may, go ahead.
Okay, well, some of this may be outdated information, but I recall reading a long time ago that this gets into relativity and reference frames and time dilation and all that. That if you watched, say, a spaceship, you had a magic viewer that you could keep an eye on that spaceship as it fell into the black hole. The closer it got, the slower we would see it move. And we would never actually see it fall into the black hole. It would just be moving slower and slower and slower over the course of time.
Yeah, I've heard
always
that.
Moving toward it, but not ever reaching it from our point of view.
Right. We'd always see it. Basically, it's an after image. Mm-hmm. Yeah, basically. And so if a spaceship, and that's an argument I've heard before. And that's sort of a different question, but that you're answering, I think. But let's take that. A spaceship moves and starts to pass over the event horizon. Well, there's going to be a certain point at which the light can escape, okay, or just barely not escape, and that point will be where the gravitational warpage is such that the light is sort of frozen in place, essentially.
Yes.
And so the viewer would always see the spacecraft at the verge of going into the black hole, but never quite going in.
Yeah.
And the fact is that is one of the arguments that I've heard a lot in the past, which is really interesting. And we'd have to test it. I'd love to watch a star being eaten by a black hole to see if we could actually see the stuff being eaten by the black hole and see if it ever goes away, if it changes in quantity and so forth, And you're right. Time dilation is another, that's right. And that has to do with approaching the speed of light. If a ship was going by us near the speed of light and there were people in the windows waving at us, to us, watching them go by, they would be frozen forever in time. If they were 99.9% the speed of light, we watched them go by. They'd be waving with their mouths open, okay? And to them, they'd be going, hey, how are you? But to us, we just see their hand up in the air and their mouth open and never moving. Okay, and so that's again has to do with our reference frame, our position watching them go by versus them watching us recede as they go past us. And they're the ones doing the moving. So that's kind of weird. Now there's another question too. Galaxy asks, could you take a 1-minute exposure of a galaxy? Yeah. I don't ever take more than 30-second exposures because at just about 30 seconds to a minute, we have to do something called guiding. We actually have to guide the exposure and make sure that we do that. And we don't do that because for a couple reasons. Number one, the remote operation of the telescope doesn't support me doing remote guiding. It does technically, but I don't have the reticle, that is the crosshair that we need to have, up so we can see it and put a star in it to guide with. And number two, because I don't want people to have to sit through a minute of me saying nothing but while I'm just guiding an image. There will be a time when I do that, actually. And once I put the reticle up and I get it up there, and the reticle doesn't have to be anything but something that I just do right here in this production environment. I don't have to do anything. I could make it up. It doesn't even have to be a real reticle from an eyepiece. A reticle is just a crosshair that we put up. Okay. And then over in this view here, in this main view over here, I could end up, putting a plus sign, the little reticle in here, and zooming way in, like I do now for focusing, and use that to guide. Use that to guide the exposure. Oh, hey Amanda, she's here. I guess.
Hi, Amanda.
Was she over at Bill's? Maybe she just woke up. I don't know. But anyway, should we just does she want to come in? I'm not sure.
Hopefully she does.
Well, if she does, I can go add her in. I'll just do it. If she doesn't want to come in, that's fine. She doesn't have to. So let's see here. Well,
Yes, call her.
I did. I am.
Super.
Hello.
And she's here.
And I'm here.
Hi, Amanda.
Hello,
Hi,
Amanda.
Carol. Hi, Mark.
How are you?
Hey, all. Hello, chat. Hello, world. I fell asleep after dinner, but I'm here.
I figured.
Yeah. I heard you say maybe I was at Bill's. I was not at Bill's.
No, actually, DW made that suggestion earlier.
Oh.
Because he wasn't sure, because Bill was also streaming, which I thought was great. That's Bill New York Skywatcher, everybody. He's one of the triumvirate, the happy triumvirate. We have P&K Space Imaging with Paul and Keith. Paul's down in Florida, Keith's in Pennsylvania. Together they do the lunar streams and planetary streams. Bill New York Skywatcher does the meteors. He's got the Lyrids meteor stream that he's doing now. And or the tail end of the Lyrids. And we're doing the deep sky. So we're just hanging out, having fun doing that. Yeah, I mean, Lyra's way down low on the horizon, so we're not really going to be able to see too much of it, unfortunately. But it's okay. We have a good view of the sky now, and we just photographed this galaxy here. This is M87, the black hole related galaxy that we've seen before. And there's a process view, and do you see that little thing right there, Amanda? Yeah, you should be able to share that. You're seeing the sharing, right? The screen sharing?
Oh, wait. I am now. Okay, let me pop out chat. Hold on, I was on YouTube.
Yeah, you don't
I
need...
think that shows really well tonight.
It is beautiful. Yeah.
Folks, when you see that, if you imagine that jet going down to the center of the galaxy where the black hole is, that distance you see is 260,000 light years.
Yeah,
it is huge.
It's going to come out a little further than we're showing it here, though. It comes out further.
This is true.
But that's okay. I mean, that's beautiful, and it's really showing very well tonight. I'm very pleased with that.
Yes.
That's an all-star photo. Really is. Very nice. Very nice, very nice. So yeah. No, Galaxy is asking, is this a marathon perhaps? Unfortunately, no. That was actually...
marathon. The way Mark streams. Just one more.
I know, that's true. I mean, but that's how it gets, I will tell you this, guys. I went outside to move the dome a little while ago, and my southern horizon, I've got these nasty clouds coming up. So I'm trying to look at a few other things. I'm going to try and grab some more stuff here while we can. Real quick, for Amanda's benefit, for those who just joined us who wanted to see it, this is the image from the center of our galaxy. This is looking at the center of our galaxy. Those are actually really stars in the center of our galaxy, okay, that are circulating around our black hole. This is called Sagittarius A. Okay, there, plus sign represents the black hole, and you can see this in this 12-year image. These are the actual stars. In this 12-year image, image compendium, I should say, you can see how stars are curving past it. Watch this one. Wow. It's going around the black hole, quite close. And so it took 12 years to make that image. 12 years. Check that out, huh? So that was just showing people that before. That's our black hole in our galaxy, right? With the stars. That's what it's doing here. But there's something there. Very, very, very powerful galaxy core with a very, very powerful gravitational field there. And then, of course, looking at our compatriot here, M87, 55 million light years away, 55 million years in the past. Hey, D. Smith. Then you can see that we're looking at a galaxy that was that the light left it just after the dinosaurs were rendered extinct 65 million years ago. And it took quite a while for the dinosaurs to actually die off. It wasn't an immediate thing. But still, it was sort of a domino effect. So let's go out now and let's check out.
Ooh, I have questions.
Okay.
I have questions on that little image that it took 12 years to make of the stars going around the black hole.
Oh, okay. This one right
Okay.
here, yes.
You said the cross represents the black hole itself.
This
that
is
little yellow cross in the middle.
that's our black hole. This is our galaxy.
Yeah.
Whip. Yep.
Okay.
right.
See that one that just went.
Yep.
That just
It whips it by
went
fast.
by really fast.
Yep.
Okay, that almost went like. That almost touched the cross.
Yeah, I mean, in
so
reality,
it's going around the black hole.
yes, it's orbiting the black hole, but it's very close. Whoa, it's very close. So
Now, if that was closer, would it have got sucked in?
if it was closer, it'd start sharing material, yeah, because it gets to a certain point, and then the common center between them, okay, there'll be a common center between them. So this one, as it comes down, as these two get closer, there'll be a certain point where they might actually be so close that that star might bleed some material off. And that would actually make this black hole more massive. So each time this star passes, it may be bleeding in a little bit of material into the black hole. Like right there, right there when it really is close to the star, to the black hole. It might actually bleed some material, and that would make it more massive, give it more gravity. And thus over time, this star could end up getting closer and closer and closer until finally it ends up being circling very close and going fast around the center of this the center black hole here, and each time losing more and more material until finally it is totally absorbed by the black hole. And then the black hole will grow in mass by the amount of the star's mass.
May I say, they did image a large gas cloud orbiting Sagittarius A star a couple of years ago.
Yep.
And when it got really close, like this star does, it ripped that gas cloud to shreds.
Yes. Yep.
And doubtless ingested some of it, and the rest, a lot of it went into the accretion disk.
Yep.
Well, that was my next part. Okay, the one that's going really fast around it, that really tight spin at the bottom.
Yep.
Uh-huh.
Okay, so the stars we're looking at, are they part of the accretion disk?
No, this is our galaxy we're looking at, and these are stars that are independent. The accretion disk is so small in this image that you wouldn't be able to see it. Okay. Now, some of the material from that star right there, wham, as it goes around, if some of that material came off the star, it could end up circulating around the black hole's accretion disk, which is, again, it's not even visible at this scale on the image here. You wouldn't even see it. It's well within the confines of the cross, probably within 1,000th of the cross. So we're talking about, but it's still a supermassive black hole.
Amanda, you might see as we zoom in there, that scale at the upper right, the size of 10 light days,
Yeah.
that is really close as far as stars are concerned. This is in the very center of our galaxy where, there's oodles of stars. And this is happening at a very fine scale there, you see, just 10 light days, 20 light days all the way across. So that's really scooting, and that's really close.
Yeah, it really is.
Okay, so they're just random stars going around the black hole, but it's not close enough to be part of the accretion disk.
That's
If
correct.
it gets
That's correct.
close enough, some of the energy from the star will get sucked into the black hole, and if there's mass, the black hole will get bigger.
Well, yes, that's correct. Yeah, and black holes will also do something else, and that is if there is no more mass entering the black hole, then because of the way they radiate away their energy, they will eventually evaporate. And so black holes can also evaporate too, and that's something that is built into the black hole physics if you look into it,
So,
Amanda, when you see those stars, I would not call them random stars. those are all stars near that black hole at the center of the galaxy. I dare say most or all of them are orbiting that black hole
For
on
sure.
different time scales. And
Yeah.
the closer they are, the faster they orbit.
Yeah, take a look
And
at this
then-
star here in a few seconds when it comes back out. All right, I'll put the arrow there, and you'll watch it. Okay. Now some are on the way away from an orbit, but as it zooms out, okay, watch this star right there. See that one? See how it's moving? It's moving, but it's at a slow pace. It's orbiting this at a very slow pace. Yep. And DW is asking questions as well about rogue black holes. I don't know about rogue black holes, DW, but massive stars that are far bigger than our sun, of course, say 30 or 40 solar masses. Stars like that could, after a supernova, stars like that could possibly create a black hole and not a neutron star. And that black hole wouldn't be a rogue. It would just be moving through space, possibly with a little different speed than the original star had. But it wouldn't be considered rogue. We wouldn't find one, for instance, entering our solar system. Not unless there was a star that went supernova, turned into a black hole, and eventually over millions of years made its way to our solar system. If that happened, we'd see its effects from before it even got close to the solar system. We could tell that would be affecting the planets in our solar system. If it was when it got to like the Oort cloud, far, far, far away, and the Oort cloud goes 3/4 of the way to Alpha Centauri, by the way. If it got about that far, we might notice some changes to objects out in the Oort cloud or the Kuiper belt, and then as it got even closer, we might notice that some of the Kuiper belt objects were drastically changing their orbits. It's a slow process. Millions of years it would take for any of that to transpire. Look at it. It just took 10 years to see this one orbit. Yeah, and Amanda, I know I cut you off too, and I was sorry, Daryl, but one of you go ahead.
Ladies first, Amanda.
Oh, mine was just more questions on the black hole. Go ahead.
Well, Mark, you said something that kind of rang a bell with me about our Oort cloud goes 3/4 of the way to Alpha Centauri.
Yes.
Wouldn't it, by definition, go halfway to Alpha Centauri? And after, if it's closer than halfway, then it would be like Alpha Centauri's Oort cloud. You know what I mean?
I do, and that's a question that perplexes me as well, because I want to understand some of the physics about and understand the orbital mechanics about how that would work. Now, what it means is that based on the theoretical calculations, that there are objects that are part of our solar system that are gravitationally bound to the sun that far out.
Right. Right.
So the question is, you're right. The question is, how can that be if we're talking about, if it's more than halfway, shouldn't they be, bound to Alpha Centauri? And the fact is, Alpha Centauri A and B together are more massive than our sun. Exactly. So shouldn't the common gravity between them attract things? And it's possible that they do, actually. And it's possible that we actually have shared outer solar systems, with the Alpha Centauri star group. I think that that's possible, but we've noticed materials out there, and these materials that we notice out there could potentially go that far out. And now it could be that they're on their way to being shared with Alpha Centauri, but Alpha Centauri is close to us now, but it's not always going to be close to us. It's just moving through the neighborhood. Barnard's star is actually getting closer to us as well. And, it's going to turn out that Barnard's star, the 6 light years away, is the next closest star to us. That star is actually going to get very close to us as well. And Alpha Centauri is still going to be closer. And then they'll all migrate apart again. So we're only at it's a temporary thing that we have right now. I'm not sure about the gravitational boundaries, though. I mean, from a celestial mechanics standpoint, you would think that beyond the halfway mark, yes, then that would happen. If the gravitational, if gravitational force is homogeneous, that is the same everywhere out from the star, and we don't doubt that it is. So I think that we should expect that to be the case, Daryl. But they are saying that our Oort cloud may extend that far out, and thus that means that maybe there is some sharing going on, for all we know.
Sure.
But I do not know.
That just always ragged me. I'm sorry, Amanda. Go ahead.
Okay, no, I'm just trying to still figure things out. Okay, so
I just want to say hi to Raising Cane, who's joined us. Hey there, Raising Cane. Nice to see you. Stacy Johnson, good to see you. And Taryn, nice to see you here too. Thank you for joining us. Sorry I didn't get to you sooner.
Yeah, we have a few new people that stumbled across, so welcome to all of you. And Kane said that they're here often, just don't jump into chat, so we appreciate you in any capacity. We're pretty friendly here, so if you ever want to jump in chat, get a question to Mark, item maybe you want to see if it's up in the sky, just send a message in chat. Now that I'm here, I am watching chat. Hopefully maybe Daryl or Mark were keeping an eye on it earlier, but I'm Danny Fan 1 in chat. My name's Amanda, so if you have anything, just throw it in chat.
Yeah, Amanda's been the traditional co-host of SkyTour LiveStream, but she's also my co-host on our radio show called SkyTour Radio on KGRAradio.com. KGRAradio.com. That's Sunday nights from 8 o'clock till 10. And we have had some replays lately, but we are going to have a live show this weekend. And we will be...
Yay!
Yes, we will be returning
to... I can get into KGRA.
Huh?
They've been having a few issues with their site, and I've had troubles for the last few weeks getting in, and I can get in, yay.
Yes, yeah, I've noticed that too. I do want to just run down real quick. I want to say hi to D. Smith, and of course to you, Amanda, and DW, and Galaxies is here, James Dugan from Down Under, Raising Cane, Shep is here, Stacy Johnson, Taryn is here, and there's a few others, and I know that the participant list doesn't always reflect the people that are actually here, and if you do put something in the chat a lot, you will show up on our chat list. Otherwise, for some reason, it doesn't, and I don't know why. We have 32 people watching, so I don't understand why we don't have the list show up more people, because I've seen people write something in here that has, and they don't show up in the chat list, which doesn't make any sense to me, And Sanjeev, welcome, and good night, I guess, because you had to head out. Yeah, we keep people up late. What can I tell you? And we're going to go right through to the clouds. I am going to just do one thing. I know we're still talking black holes, and that's fine. We can keep doing that. But I do want to take advantage of this right here. I want to go check out this galaxy right here. I like this galaxy. It's called the Silver Streak Galaxy. And we're going there right now. Okay, so here we go.
Okay, my question about the black hole while you're setting that up.
Yes. Please feel free.
So stars going around the black hole.
Yes.
If they're close enough, they're in the accretion disk. And if they get closer, material can get sucked into the black hole.
Yes.
To expand the black hole.
Yes, in mass. Make it more massive, yep.
What has to happen for it to get sucked into the singularity point? How does that happen?
Well, the singularity point is in the middle of the black hole, and all it has to do is enter the black hole, and it will eventually...
If some material is getting sucked into the black hole, is it all going into the singularity?
Yes.
Okay.
Yes. And let's keep this in mind, okay? There's something that the radius of that black hole's what you're calling the accretion disk. That's the spinning material that's spiraling around the black hole and possibly going into the black hole. That radius is called the Schwarzschild radius. Okay, Schwarzschild. And the Schwarzschild radius is a specific formula for calculating it. It depends on the mass of the black hole. So if the black hole increases in mass because it grabs stuff, then its event horizon radius grows. Okay? And so that means that the black hole can be massive, like this one here, and that we just saw in the M87 galaxy. Its radius of its black hole event horizon is several times the size of our solar system. That is Earth to Pluto by about 3 times. That's just the radius of this thing. Imagine that. A whole solar system and the black hole. So that's a lot of material that's trapped inside this black hole. See? A lot. I'm going to just take us eastward here a little bit to bring us back to where I think we'll have the silver streak. Okay. So do you get that make sense?
I think so.
Okay. I'm taking 15 seconds at 12,800 on the Silver Streak Galaxy. Should be right about here when we come back. Should be right there. In fact, I'll leave my cursor right there to see if I'm right. Oh, I'm so scared. I hope it is right. Well, what happened there? Oh, duh. There it is. Look at that. Look where my cursor was, and look where the galaxy is. Ta-da! And yes, there's one out there. And let's just do this.
Marcarian L. Belmont posed a question a couple of times.
Oh, yes.
I think about what we talked about earlier about it. Accretion disk is clearly seen in New Horizon telescope pic,
Yeah.
correct? We talked about event horizon versus, or the accretion disk versus what the so-called shadow.
Yes.
I assume that's what we talked about at the top of the show.
Yes. And that's the thing that it's the distinction is kind of tricky, because we cannot see the actual event horizon. The event horizon is characterized by the absence of light, which is what a shadow is, the absence of light in a particular region. So technically we're looking at the shadow of the black hole. And the other reason we're seeing it as a shadow is because what made the black ring, of course, is the event horizon location. But really what made that ring is the fact that it was ringed by light. Now, this is the real tricky part, okay? So I'm going to try to explain this as best I can. If you had a disk, all right, and in the center of that disk, you had a black hole. All right. If that disk was flexible, or not flexible, but if that disk was just, say, a rigid disk of, say, bright objects that are circling the central object, okay, and you're looking at it from a distance, and that black central object had very, very powerful magnetic and gravitational fields, so that it could warp the space around it. Then the light leaving the disk on the far side from your perspective, it was flat and edge on to you, even like this Silver Streak Galaxy, okay? Let's say it was edge on like this, okay? You can see the dark lane here in the galaxy. Well, let's say that this bright spot here, let's say that was the black hole. On the other side of the galaxy is the other side of this disk of the galaxy. Well, if there was a supermassive black hole in the size of the one in M87, was in this galaxy, then what we would notice is that this galaxy's light from the far side, as it left the galaxy and went up this way off the galaxy's plane, then it would be bent around toward us. And so we'd see a little ring around the galaxy. All the light from the galaxy, and if this was the accretion disk, all the light would be bent and folded around the galaxy and look like a ring to us from no matter where we looked at it. It would really have that look from everywhere. And of course, the material moving toward us, let's say that this galaxy rotates this way, okay? So out of the page, into the page, out of the page, into the page, right? As it did that, okay, the stuff coming toward us would be brighter because it's higher frequency. And the stuff going away from us would be shifted toward the longer wavelengths, redshifted, and would be lower energy, so it would be dimmer. And that's how it works in the radio spectrum, which is what we did. That was a radio telescope view of that black hole. So that means that that one side would have that crescent of bright stuff, and one side would be dimmer, just like that black hole. That was Einstein's prediction, and the prediction turned out to be absolutely 100%, 110% accurate.
And that's just a good old Doppler shift too, isn't it?
Yes, but when you're looking at it in the radio spectrum, it's basically looking at it's shifted toward higher energy versus lower energy. So, and that's how that looked to us. What an amazing thing that was, though, huh?
Oh yeah.
Yeah, and so using this galaxy as an example, if this was the accretion disk, the accretion disk in a black hole basically circulates the black hole, and stuff spirals into the middle where the the black hole grows in size because it's taking in more mass. And but because the black hole warps space around it, and the light follows that warp, as light leaving this accretion disk on the far side of the galaxy goes up, it's bent toward us, so it comes up over the top of the galaxy and goes right toward us. And that's why we see light over the top of the black hole and it looks dim, and that's actually why we see a ring around the black hole. We're not looking down on top of an accretion disk. We're actually looking at the warped nature of the accretion disk that is occurring because of the strong gravitational field that's warping space, and light just follows space, and it follows the curvature of space. And so we see where light's being taken because of the warp. All right, and that's the whole point there. That's what that's all about. I hope that makes sense.
To differentiate between the accretion disk and the so-called shadow,
yeah,
I think I read somewhere what they call the shadow is that where the light is actually moving toward the black hole instead of toward us.
I would guess that's probably where the light is circling inside the black hole because it's inside the event horizon. It's actually, space is warped so badly that light. When they say that the black hole has such strong, and this I hate that misleading statement you always hear. The black hole's gravity is so strong that not even light can escape it. Well, if you think about that, it's like, but wait, light has no mass, so how come gravity affects light? It shouldn't, and it doesn't. It's actually affecting space, and the light is following the curvature of space. So that's what is causing light to move in different ways, you see. So inside that event horizon, that area beyond which the warpage is so great that light cannot find a path to us, it's only circulating within that event horizon and toward the singularity at the center. And that's how that's working. So unfortunately, once that's past that spot, once it's within that Schwarzschild radius that we mentioned a little while ago, then there's no way that this is going to be visible ever again. I want to welcome Rich to the SkyTour LiveStream. And you came at a good time, Rich, because look, we have one galaxy, two galaxies, 3 galaxies, 4 galaxies, 5 galaxies in this view. 1, 2, 3, 4, 5. Beautiful galaxies.
I actually thought those are galaxies too.
Yeah, right? Aren't they beautiful?
I'm getting used to these little smudges being whole galaxies.
Little smudges, how dare you? Yes, I know. Little processing here to kind of show them a little bit more. You can actually see, boy, these are just beautiful.
Do has a question.
Sure.
Based on what you just said.
Yeah.
Doesn't gravity cause light to bend due to black holes' massive gravity?
Actually, dude, that's good. All right, that gives me a chance to clarify. Let's imagine that you take a giant rubber sheet and you throw a bowling ball right in the middle of it. It, of course, will stretch the sheet down. And let's say that you throw a marble out onto the sheet. As it goes down the sheet, it's going to follow the curvature of the sheet. And maybe if it gets close enough to that bowling ball, it'll swirl around the bowling ball and then start to come back up and then go down and swirl around again and finally just, go clack up against the bowling ball. Because, of course, it's losing energy as it's rolling along this rubber sheet. That's what happens with a marble and a rubber sheet. So what's happening there, see, is if you think of that bowling ball as a black hole and that sheet as space is being warped by gravity. And the marble is the light particle. And it just follows space. So it's following that curvature. So it's not that light is being bent, so to speak. Space is being bent. And light is just going in a straight line as far as it knows. See? And that's what happens. You know? So yeah, but you have to think of it that way. I never liked the bowling ball and the rubber sheet analogy because it's two-dimensional. It's you know, it's like a plane, and that's not how these work. This is three-dimensional. So just imagine a much more complicated setup, you know?
Well, it's an analogy, and it helps get the idea across. I mentioned that YouTube video where the professor showing his class exactly what you just described. He put a big, heavy ball in the center of a rubber sheet.
Yeah.
He zips marbles around it, and if your trajectory is right, they'll go into orbit around it.
Yep.
They will lose energy over time, though, due to friction.
That's right.
The sheet, they eventually fall into the center.
Yep.
So, like any analogy, it breaks down eventually, but it is a good demonstration.
Yep. Hey, Lynn Lair, welcome. I just noticed you're here. I didn't see you before. Galaxy, you mentioned the fastest thing in the universe is light, as we know, and it doesn't have fast enough escape velocity to escape the black hole. It's actually the warpage of space near the black hole is so great that the light is forced to go in an orbit ever so more tightly closer to the center of the black hole. And that's why it can't escape. It's not traveling, it's still traveling at the speed of light inside the black hole. It hasn't changed. But it's now trapped because the space around the black hole has been warped by the black hole's gravity. That's just it's a two-pronged thing. You can say that, light is being bent by gravity. Well, light is following the bend of space created by the gravity. There's two things there. Light is following the bent space that was bent by gravity. So gravity bends space, light just follows space. So if space is bent, light goes on a bent path as well.
May I add something here?
Yeah.
If I remember correctly, one of the first proofs of relativity after Einstein, released it, was they were watching Mercury as it passed very close to the sun. This may have been during a solar eclipse,
yep.
if I remember correctly. And the position of Mercury in the sky, because we were seeing it over the edge of the sun, well, the sun actually warped the space around itself, and that caused Mercury's position in the sky to change.
Yep.
When it was close to the sun.
That's right.
And that showed the curvature of space-time.
That's correct. And that
happened well over 100 years ago.
Yeah. And so that's how that actually worked. In showing that Einstein was correct is something that I think physicists are just want to do because they have to show that their belief system, their functionality, all of their work that they've done hasn't been for nothing. We want to show, and I'm perfectly willing to accept that he could be wrong on certain things. In fact, I thought he was in the past. I didn't actually believe in the black hole theory as posited years ago. I just thought it was just too far out there, But honestly, I get it now. Hello, Ralph. Ralph is here saying hi.
Ralph has a question.
Okay, if you can grab that for me.
Yeah, he wants to know, why does a black hole only pull in matter from one side instead of all directions?
That's a very good point, Ralph. In the same way that a solar system only goes planar, as like a flat plane around a stellar object like the sun, so too does material circulate a black hole in the same way. the concept of celestial mechanics, the concept of orbits, the way this all works is that because you have many different interactions between objects moving from all directions, they tend to stabilize out into a disk. And so we would end up seeing that maybe there was planets that were coming in from the north and the south and the east and the west and all compass directions at some point from all over the many different elevations. But over time, they would level out. They would establish a plane. It would set up a plane or orbital path. And so too happens with the accretion disks, the disks around black holes. Now, material is pulled toward a black hole from every direction, but it would tend to settle out into an accretion disk, into a disc-shaped pattern over time. That's just the way it happens, and it's part. I mean, I would really love to show. I could show this. You know, I wish I had like a live TV thing here. We would just actually show it. I mean, I got this little. You know, you've only got me and this little tiny camera, and I'm using blue light tonight.
I was gonna comment on that. I love that color.
Oh, you do?
That's like the color of my room.
Oh, very cool. Yeah, well, you know what I've been using? I've been using the red for so long, and I figure, well, tonight I'll just, you know, I could use the red, and I mentioned it before, because, you know, there's the red. Okay, I could also use like an Arctic Aurora color. This is like an Arctic Aurora kind of color. I could just use bright lights. Gross. Okay, I could use dim light. You know, I could use different colors of all kinds, but then I like my red is just good too. But the CIC, that one is the one that I was using for tonight. I thought that would make a lot of sense. I could
It's
do.
a nice calming,
It
relaxing
is.
color on the eyes.
It is. It is. In fact, if you notice on ships at sea, especially naval ships, they use this very color in their computer areas because it is a color that does help you focus, and it is actually a color that's very easy to deal with over time. And in fact, it's a better color to exist in overall, but it's okay. So I took a longer exposure here just to check out these galaxies again. Oh yeah, look at that. Those are beautiful. And those who have joined us before may recognize this song. This was the song we used earlier in our other SkyTour LiveStreams as a startup song. And that's a song that I enjoyed it. It's called Dusty Fingers. And now we're using another song that's called, what is it called? I'll tell you.
I don't hear the music tonight, but it's making me worried if chat can hear Daryl and I. Daryl and I have been very, very low on the last few streams.
I don't hear the music either.
You don't?
That's okay.
All right. Well, let me just.
That's okay.
No, I know, but I'm gonna just see what's going on here. I'm gonna stop and then start again. Sharing. All right. Don't give me that.
No, I just find sometimes the music cuts off what we're saying and stuff, and it makes it.
Okay. There.
Yeah, I hear the music.
Well, don't sound so happy.
Folks
This
in
is
chat,
our start
can
of
you
song.
hear? Folks in chat, can you hear Amanda and myself?
Being in,
There were people thanking you, Daryl, earlier, so I think that's fine.
Okay, good.
Yeah, see? And Taryn saying I hear you fine. Yeah.
Super.
People did dismiss it. We can hear you in the music. Yeah. Okay. We hear everyone. Yeah. Yeah.
And I hear the
but
music
Dew
now
says,
as well.
Dew says, I actually hear Amanda and Daryl great tonight.
That's good. Thank you very much, guys. That's very
The
good.
last few streams. Yeah, no.
I'm not sure what that was. The problem earlier in the past stream. I think it was only the past single stream we had a problem, right? I don't remember it being a problem before that. I think it was only that one stream we had a little issue with the sound at your end, and I don't know why. It could have been here or not, you know. Justin, welcome, Justin. I think.
I'm good, Justin.
Hey, No Life, how you doing? Yeah, so there's a few people here that we've had here before and some that haven't been here before, at least that I haven't seen, which is kind of interesting. I'm glad that you guys came along. I know Bill New York Skywatcher is doing his thing tonight as well. And
Hopefully he's having some luck. I don't know.
Well, the Lyrids, he's looking at the leftover Lyrids. The LLs.
Leftovers, so the peak already happened?
I believe it did. Am I right, Daryl? I don't remember the peak on the Lyrids myself.
Yes, the peak of the Lyrids was overnight, the 21st into the 22nd.
Yeah.
A few days ago.
Yep. Okay, so hey, I don't have all the answers, but sometimes I just want to get an answer and find out if it's right. If I doubt myself, I will ask. I'm not proud, and I'm not Mr. Know-It-All either. All right, we're going to Marcarian's chain here, which is another set of galaxies, which is absolutely astonishing. If we can check those out, hopefully. Okay, let's see now. Okay, we got some stars in here. I think we're there. Let me just go back to our planetarium view. Okay, we should be there. Yeah, we should be there now. Definitely. All right. Okay. Let's bring up our telescope control. And our telescope control says we're okay. I'm going to move eastward a little bit. I'm finding that things tend to go eastward a little. All right. And then we'll do 20 seconds at 16,000. 20 seconds on the clock. 16,000 for the sensitivity. And away we go. And these galaxies should be pretty bright. So we'll see what we can see. And this is a special set of galaxies called Marcarian's chain. Daryl, do you know the history of Marcarian's chain by any chance?
I've heard it. I don't remember the details offhand.
Okay.
I assume some guy named Marcarian saw it first or named it.
Yes. Yep. Well, let's check it out.
Yeah, when you were at the Silver Streak Galaxy and noting the other background galaxies nearby, first thing I thought of was Marcarian's chain.
Oh,
You're
yeah.
in the neighborhood.
Yeah, that's right.
Here we are.
And here we are. So you can see, now this is Marcarian's chain here. And if we just do a little processing, I'm going to do a little bit more to kind of pull those out. I hope you guys don't mind my playing around with trying to get just a little bit more out of the singular image shots that we take. Okay, and that's a little bit of this is a sharpened view, this is an unsharpened view. You can see a slight difference in how sharp they look. That's unsharpened, and I've added a little sharpening there. Okay, and that gives you an idea, a little bit more details visible, but it also tends to ruin some of the details, so I tend to leave it off. Hey, No
Tammy
Life.
has a good question.
What's that?
Tammy has a good question.
Okay.
She
Well, hi,
says,
Tammy.
When the ISS is flying above, can they see this stuff too? What kind of equipment is on the ISS to kind of check things out while they're up there?
You know,
Investigate while they're up there.
that's a very good question, Tammy, and I would like to answer that for you. First of all, there's not many places where they have quote-unquote picture windows on the ISS. The only place is in the cupola, which is a series, looks like a tank turret, and it's actually aiming down toward the Earth. So then there's small windows here and there where they can put cameras against the window glass and take photos. But there's no big telescopes up there at all. And because the ISS is moving at 17,500 miles an hour, as it's traveling in orbit, it's not easy to get a photograph of the stars that's sharp and clear. And it usually has to be done with very specialized equipment, which they have had there at times. And so when they take photos of the sky from the windows of the ISS, they tend to be out of focus. But you know what? I would take an out of focus shot every day of the week if I could be on the ISS. No, I would. I'd probably be getting motion sickness too, and I'd probably need all kinds of medication to keep myself from puking. And And if you ever wondered what weightlessness feels like, you've all felt it. If you've gone on a roller coaster, that moment you go over the top of the hill and you start coming down where everybody screams, that feeling in your stomach right there, that feeling right there where your stomach's doing those flips and you're going, and you almost don't breathe. That's how they feel 24 hours a day. Just imagine that.
I think that would get old real quick.
Well, there was several people that paid a couple $100 million to go up as tourists, and they were sick the entire time they were up there. They couldn't get past it. So, but then again, I was on a nuclear submarine as a guest of the Navy for a while, and I did a special project, and they said, "You want to go to sea?" And I said, "Sure." So I did, and the entire time I was at sea, I was seasick. But I would say this, it's the best time I had being seasick. Okay, I still managed to figure out ways to enjoy myself, even though I was, quite under the weather. So that all said, it's just it's a matter of letting your adrenaline take over, and being able to figure out how you're gonna deal with it, But I'm not gonna say that it was easy, because it certainly wasn't, But I will say that every day of the week, I'd take blurry photos of the stars as long as I could do it from space. I would certainly love it, Now, I was responding to another question, too, which I didn't get to. Let's see here. I'm looking, guys. I'm looking in the chat here for a second.
A question I missed?
Well, it wasn't in caps. That's the problem. See, if you had questions...
Not a lot of them are.
I know, and I hope that... But if people ask questions, I hope they put it in caps. Darn it all. Oh, that's not it.
Do you know what it was about?
Nope.
I've been trying to grab all the questions, unless it was comment that you wanted to touch on. I think I've got all the questions so far.
Okay. Taryn, actually, to answer your question, how did I get invited to go on the sub? I've been doing work for the Navy since 1995, special operation work type stuff. Not special operations, but special projects. Let me be careful. And I was doing a few projects that were, very interesting to them, and they said, as a thank you, would you like to go for a ride? And I was like, yes. I said yes before thinking it through. And so I ended up being enclosed, basically in a sewer pipe with end caps for a long, long time. And I spent my time when we were on the surface. I spent my time, because the sub's rocking and rolling on the surface, and man, when of course there's no windows in a sub, and when you don't have windows, your brain is totally confused by the motion, and it takes people some time to get used to it. I just couldn't do it. So I spent my time climbing up the little tiny ladder, 25 feet straight up, stainless steel ladder rungs that were only about 12 inches wide, climbing up all the way to the top of the sail on the top of the sub, and just hanging over the edge, just not throwing up or anything. I never threw up, but I was just sick. And just looking out at the horizon the entire time. Just like, okay, as long as I can see something. Of course, when I went back down, I was covered in sea spray. And now you're going down stainless steel ladder, 25 feet. And if you accidentally slipped, because it was easy to slip, because it was all steel and, it's all slippery. So my feet slipped a couple times. It was really funny to actually think about it, later, because... had I let go, it would be like cling clong, cling clong clong, cling clong cling, poof. You go all the way down, because there's a hatch in between the top and the bottom that you would slam into, and then of course continue the fall to your probably death. But subs are not gentle places. Either. When I was in the engine spaces of some of these subs, there's a lot of if you tripped and fell, you'd fall on sharp steel edges and things that were like for walkways and things like that are in the subs. It's not a gentle place. You fall and hit your head, you're going to hit something that's going to hurt and cause deep gashes and all kinds of injury. So it's really crazy. But it was a fun time, and of course that was that was the time when we actually had that unknown submerged object that went racing through, that I've talked about before. An object that was on the sonar. Apparently, the kid that was doing the sonar yelled out to the con. He said, con sonar, fast mover, fast mover. And I thought, because I was sitting in the sonar area trying to just unwind and let my stomach come back to some sense of normalcy. And the XO, the executive officer, comes around the corner to see what the kid's got in the sonar. And I didn't hear everything he said about the bearing and the range, but I did hear him say how fast it was moving, because he said it loudly and kind of with incredulity. When asked, he said it's moving several hundred knots, sir. Several hundred knots. This was an underwater object. And some people call them jellyfish, I think, and other people call them fast movers. And the fact of the matter is, no one knows what they are. Are they extraterrestrial? Maybe. Maybe so. But, we don't know. Because nothing we have on Earth can travel that fast underwater. But boy, oh boy, this thing did. And I tell you this, I was awake for the rest of that trip. And I'll tell you this, too. Being, that I was doing special work for the Navy, and I had, special qualifications, I got up and I went over to the executive officer and said, "Oh, XO, I'm familiar with these fast movers. Is there anything I can help you with?" And he looked at me and he smiled and he put his hand on my shoulder and said, "Mr. D'Antonio, are you having a good trip?" I said, "Yes, sir, I am." And he goes, "Let's keep it that way." And he walked away. It's like, oh, geez. So I guess the bottom line was I basically was put in my place. But I was kind of full of myself, too, at the time, thinking, hey, I'm a big shot now. I was asked to be on a sub. Hey, check me out. And being Mr. Big Shot, obviously they turned around and said, haha, go sit down and shut up. I said, okay, sir. So it was kind of a put in my place thing. And I was actually grateful for that lesson, actually, because not enough people get that life lesson to be put in their place when they should be, unfortunately. So, I was, and grateful for it. But a couple years later, I had to do a job for the Joint Chiefs down in Washington, D.C. And I made friends with a couple of the chiefs. And when I was in one of their homes, actually, I asked one of them, I said, "Hey, what can you tell me about this fast mover program?" And he kind of looked around, and he looked over at me, and he says, I can't talk about that program, Mark. I'm sorry. And I was like, wow, did he just say what I thought he said? I can't believe it. Oh my. So, the bottom line is that it's a program that exists, and it's for tracking objects of unknown origin. And our Navy's doing it, and they're instructed how to handle it. See, the sonar guys, I've heard this from other submariners too. They were never allowed to not know what something was. Well, so what do you do when something is truly an unknown? Well, DXO told this kid what to do with it when the kid said, "What do I do with this, sir?" And he said, "Log it and dog it." That's what the XO said. Log it and dog it. And I forget what the kid's name was. So the kid said, "Sir, yes, sir."
I'm sorry.
No, it's okay.
Mark, aren't the Russians supposedly working on, what do they call them, supercavitating torpedoes or something?
Oh, yeah.
That are supposed to move very fast through the water?
Yeah, 200 plus knots. But the thing is that they're the loudest thing in the ocean. And this thing on the sonar was almost quiet. You almost couldn't tell it was there. And then it was there and it was gone. It's like very fast. Very fast. And so that's why... And he confirmed it wasn't a machine anomaly either, which was the other interesting thing. So anyway,
I'll be back in a sec, guys.
Okay, we'll be here in a sec. So anyway, that's what we encountered out there, and I have no idea what it was. Still don't. And to this day, all I keep thinking of is we have all these galaxies in this view. Marcarian's chain, these two here. Okay, there's actually another one down further. Actually, if I just do this and I slide this up a little bit, you can see it just here off the bottom of the view right here is another one down here. There's one right here. There's one here. There's a faint one there. There's one here. There's one there. There's one there. There's one there. I mean, it's endless, right? And it's like these galaxies, any one of these galaxies could be the source for an extraterrestrial civilization, possibly. We shouldn't be the only one. And every one of you listening to this SkyTour LiveStream knows that. Every one of you out there knows that we are probably certainly not alone. I say probably certainly, right? And that's funny. We are certainly not alone. And so I think that basically we will probably find out at some point that they have been here for a long time. And where would they go? Well, they would use the oceans, wouldn't they? I would, because we don't go in the oceans. Any civilization worth its salt can see that we don't go in the oceans, you know. We just don't. So, you know, I think that's probably a without without a doubt is a very likely scenario. So, and we're just looking at these very bright galaxies over here in Marcarian's chain here. Okay. And we looked at the eyes, which are these two over here, and then they had Marcarian's chain here. And these two guys over here. And I just want to see now if we can go... where's the Sombrero? The Sombrero's down there, Spica.
Yeah, just west of Spica.
Yeah, so let's go down. Spiker. Where's Spiker?
Right there.
Yeah, and there is the Sombrero. Okay, this is the Sombrero Galaxy. And where are we looking? Well, in our view here right now, we're going to be almost due south, which is good. Okay. And we're going to be looking at the Sombrero Galaxy, so we should be able to look right at that galaxy. All right, and we're going to go to that galaxy. Thank you very much. All right, and here we go. We're on our way to the Sombrero Galaxy. It's a wonderful galaxy. It's 29 million light years away. So you can ask your real estate agent to help you find a good place there if you like. It is definitely got some good scenery and some good views. Yeah, as if. So here we go.
Those 3 stars again.
Yep, that's right. You remember those 3 stars?
Oh, yeah.
That's right. Can we see those 3 stars right there? And they almost point right at the Sombrero, if you remember.
Uh-huh.
Boom, boom, boom. And where's the Sombrero? It's over here. So let's get our telescope control up and let's head a little bit eastward to bring that more centered. So that's now the Sombrero should be right about there. And let's take a 20-second pic at 16,000 ISO of the Sombrero Galaxy. And we are off and running in the Sombrero Galaxy. For those of you that are truly interested, which I know every single one of you is, the Sombrero Galaxy, again, is almost 30 million light years away. And in terms of brightness, it's actually it's 8th magnitude, so it's actually a pretty bright galaxy. But with its current elevation above our horizon here, the light becomes dimmer as it gets closer to the horizon. It's called extinction. And this galaxy has extinction that makes it now 8.2. And now 8.2 magnitude 8.2. So that's just the way it works. And so now let's go see what our Sombrero counterpart. Oh, we got a green. Know what that means? Oh boy, that green and the red, that means we've got clouds. But look, these 3 stars go ding 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 and point right at this beautiful Sombrero Galaxy. Look at that.
Still a nice look at it.
Oh yeah, it's a beautiful view. Yeah.
See the dark dust lane.
Oh, that's a beautiful dust lane. That dark dust lane, see again, it's in the plane of this disk. And this material could have come from any direction, but then it would settle into a disk-shaped cloud and circulate kind of. Now, the disk of this galaxy is essentially like the accretion disk around the black hole. It's the area around the black hole, area around the galaxy where material is circulating in a regular orbit. And that's what we got here. Okay. I'm drinking pomegranate cranberry juice. Abducted Christian ufologist. That's funny. And Booma, hey, how you doing? Good to see you guys out here. Thank you. And Papa Tom, so nice to see you here. I don't sell the pictures, Papa Tom. I just make them available to everybody. You know, I don't need to have my signature out there on photos. I just want everybody to get some really cool photos. That's why I put them up on the SkyTour LiveStream Facebook site. Make sure you guys join SkyTour LiveStream on YouTube, folks, so you can actually see the pictures. It's all free. I don't charge anybody for this. My observatory is I've gone through some major changes with it because we've actually the shutters on the observatory that open up allow the telescope to see through the opening in windstorms have actually been blown off 3 separate times and destroyed 3 separate times. And the makers of the shutters actually designed a hold down system which they sent me for nothing because they're such good freaking people. These are Canadian Telescopes, by the way. That's the name of the company. Canadian Telescope, yep. And Babak Sadehi is the guy who owns it and runs it, and I respect him greatly. He's actually done some marvelous things. And, he didn't just sell me an observatory and then just, brush off his hands and say that now he's done. No, he stands by his product. And we're like 2 years into the ownership of this observatory. 2 years. Okay, 2 years. And he's still sending me parts if something breaks or whatever, because he's trying to make sure that he has the best product there is out there. And I would proudly accept him as a sponsor of SkyTour LiveStream if he wanted to. But yeah, this is the Sombrero. Yeah, and we're looking at it 29.2 million light years away. In fact, in spite of the fact that we have cirrus clouds, it doesn't look bad. I'm very, very happy about that. But it is kind of down low. So what I might want to do now is take us back up a little higher and maybe see if we can get back to something over here. How about this? Should we try M53?
That's globular.
Yeah, I know.
That M3 is just up to its upper left. You ought to check it after that.
Yeah, we will. We've looked at M3 last time. I'm hoping that we're okay with the dome. With that, I'll have to check that out. But let's just actually let's go check out M3. I'm sorry, M53. And knowing, let's put it here.
We've looked at both of these before.
Yes, we have.
On the same viewing session, and both are globular clusters. It's interesting to note the difference between the two, though. They look quite different to the eye.
They do. All right, so here we go. Let's go find out if we've got enough of this to go around here. Let's first do this. Okay, moving in. Okay, coming into view, you can see the stars coming in here. Okay, and we are pretty well stopped. I won't wait because I might be on cloud time and I've got to probably pay attention to that. So I'm going to go eastward a little bit, more than we need, and then pop back west, just a little jog. And we should be golden now.
Mark, are you removing backlash in the drive when you do that?
Yes.
No. Okay.
Yeah, you figured it out.
What I thought.
Yeah. Well, I'm moving eastward because of the alignment. The scope needs to be realigned. It's got a slight westward center. It's west of center many times when I want to go to an object, so I have to move it eastward anyway. But then I jog it west to kill the backlash.
Right.
And the backlash, folks, is like we're dealing with. These have gears in them. The telescope has gears. Oh, look at that! It's gorgeous, and that's really pretty. This is M53.
Thank you. Your support always means so much. Thank you, guys.
Hey, dude, thank you. Just in time, C2, you get this beautiful globular cluster for your troubles. Really nice. Yeah, this is M53. It's a globular cluster that's actually one of what's called the halo objects around our galaxy. They circle the galaxy in a halo. Now, what's odd is I've been telling you all about how things settle into a disk, but these don't. These are in their own orbits, sometimes from very high galactic latitudes and longitudes all around the galaxy. Latitude is the up and down, and longitude is, the azimuth, the look angle to the left and the right and all the way around. And from very high angles, these things can be orbiting the galaxy. This is just slightly out of focus. Not out of focus, but slightly a little bit elongated in the star images. So just a tad bit off here, but not bad. Not bad for what it is. And this is a processed view of that. Isn't that pretty? It's really pretty. You can actually resolve it. You can see all these stars. I mean, globular clusters look like exploding snowballs of stars. That's what I liken them to. And if we go to our if we go here, okay, Measure 53 here, this thing is, according to this, it's actually 58,716 light years away from us.
Approximately, as Mr. Spock would say.
Yes. It is approximately 58,000 light years, Captain. Thank you, Mr. Spock. I am so happy you're here with us on this crew. Yeah. Exactly so.
Was that the robot chicken version?
Yes, exactly.
Nice.
Yes, robot chicken.
That
is
yay
very
gave
fun.
it away.
Yeah, right. Yeah. All right, so there we saw M53, and now let's go do, as Daryl says, M3. Okay, and let's pop out of here. Let's do, where'd my M3 go? It's up here. I hope we are okay dome-wise to view this. If not, it's okay, because I still need to see what the cloud situation is out there anyway. All right, let's move to this area
And
here.
speaking of which,
Yeah.
okay, I hope I don't mess it up. Did Leonard Nimoy, was he the original host of In Search Of?
Yes, he was.
You can actually see a new version of In Search Of.
Yes, you
The
can.
premiere episode is on aliens, and guess who they asked to talk to?
I don't know.
There's some guy named Mark.
Oh.
He's really good. Unfortunately, he wasn't in it for very long.
Yeah.
Then again, I'm biased, but
Actually, they had me describe that submarine story for that episode.
it was so long ago since I saw it. I forget now. I did watch it, though. I specifically looked for the premiere to find it.
Cool. Karen's asking another question, by the way. If you can just grab that real quick. Karen Belmont.
Yeah, she wants to know, and I guess it was on what we were just looking at.
Yeah, the globular
is that
cluster.
considered a globular cluster? And can they, I guess, have black holes in the center?
I don't believe that we've seen black holes in the center of these things. But I'll show you to bring this over. I'm in 4K mode now, so you can actually see M3 right here. And so we're seeing it kind of with a live view. All right. And let me now show this, just increase the brightness here so you can actually see. So now you can see what it looks like. All right, this is now live in the camera. This is a live view, which is neat. I like doing a live view for folks because that's kind of cool. So then I'll drop it back down. Go to 16,000 ISO and drop out of the 4K video mode. That video was preserved on my camera. And now I'm going to take a picture for 20 seconds at 16,000, okay? And here we go. We are now taking the picture. So this is
What's
gonna.
the new host's name you've in search of? He's the one that plays the new Spock in the new movies.
Yeah, that's Zach Quinto.
Zach Quinto.
Yep, Quinto. I'm calling him Quinto. He might say Quinto. I don't know, but I think or Quinto. I think it's either Quinto or Quinto. Zach. Oh my. Oh my.
See the difference between M3 and M53?
Oh, that is a stunning image.
Yeah,
Yeah.
that's glorious.
Yeah, let me just center it up. Let me just go here.
That's pretty too.
Oh, it's
I think
gorgeous.
I don't know. The other one looked a little more bluey, but I think this one's maybe a little.
Well, if anything, the stars shouldn't be blue. They should be more yellowy. Keep in mind, I have a filter on here which tends to make images look a little more blue than they should be, because I am removing all of any of the light pollution that might be out there. I'm removing it. Isn't this beautiful? This is probably the best image of the night in terms of looking at a star cluster. Check that out.
Yeah.
Let's go zooming in. Huh? Look at this. Moving into the star cluster. Look at that.
Looks like somebody poured a spoon of sugar on a black tablecloth.
Yeah, or it looks like we're looking at a specular reflection on a driveway at night. You know, it's wet on a wet driveway. Yeah, we're looking at a light reflected in a wet driveway.
Uh-huh.
Actually, I took a photo like that as a kid and fooled my friends, telling them, hey, look, this globular cluster I took a picture of. It was actually just a driveway. My driveway spilled water on it, and I took a picture of it. And it looked just like stars. It looks just like this, actually. You know, very cool. This is a gorgeous cluster. M3 is beautiful, and this is the scene. We don't have any bleed through. I think we have a faint object right there. I might have to go check to see if there's a galaxy there, yes? Shall we?
Sure.
Let's go see what's next to M3. Well, yes, look at that. That's the galaxy we were just seeing. This is the shape of our field, by the way. So you turn your head a little bit to the left. With M3 centered up, we should see a galaxy to the right. So when we come over and look here, okay, and indeed, look what we see. A galaxy to the right over here, as expected. So that's what I like about, combining this planetarium program with the telescope for the John Zach Memorial Observatory, because it allows us to see things in the right perspective. And it puts the location, the image on the screen is shaped in exactly the right place. And it's exactly the right size. So I just love the way this works. So that's why I'm very happy about that. I'm very happy about this, that we keep doing this. I see, I want to just say hi to anybody I haven't said hi to yet. If you have not said anything to me lately, you may not show up in the chat participant list. But if you have, then I would expect to see you there. But to give you an example, something's wrong with the way YouTube shows the chat participants. Karen Belmont's been typing things all over the place all night long. She doesn't even show up as a chat participant. I have no idea what's going on there. And I don't know why. Unless, I wonder if it has to do with the fact that, see, Amanda and Daryl, do you see how Karen Belmont's avatar is just a generic object, but
Yeah.
Right.
Taryn is got a picture there. Papa Tom has a picture. D. Smith
Is
has
it
an
only
image.
people with pictures?
Maybe it's only people that are logged in with pictures. You notice that none of these have.
Maybe.
Oh no, James Dugan. Look at that.
Yeah.
Oh, but he has a wrench. See?
Oh, but he's a mad.
Yeah. See that?
Hmm.
I'm thinking that's why we're not seeing them. Folks, we're just working through this. I'm trying to figure out why I don't see you guys in the participant list when you should be in the participant list. Wow.
Welcome to live radio, folks. Sometimes we do this. We ponder.
Well, yeah, well, it's okay because we got a beautiful view on the screen anyway for people to see.
Yes.
It's just stunning,
Yes.
you know. I mean, where do you see clusters like this, for crying out loud? This is just beautiful. And wait till we actually have M13 to look at. Okay,
Oh, yeah.
M13 looks even better. Incidentally, this, you know, we looked at the other one. It was 58,000 light years away. This one is 20,000 light years closer, practically. This is 34,000 light years away. So this is actually why it looks much better and better resolution. In fact, if we just go back real quick, I show you, this is the one we are in now, and this is the previous one. Okay, you see the difference between that one and this one. Okay, this is bigger and brighter. The globular clusters tend to be around the same kind of size, but they can have many more stars and be denser. It's just a really interesting thing here, you know. I would like to see what's going on in the center, and I know that some of you suggest, oh, what about a black hole? I don't know.
You touched on that earlier about black holes not being in globular clusters as a general thing that we know of.
Yeah.
At least not supermassive ones. The kinds of stars that form globular clusters, though they're called population 2 stars, if I remember correctly, they're actually some of the oldest stars in the universe.
That's correct.
They came before the population 1 stars, and the population 1 stars are the ones that are richer and heavier elements. But also, I think the Pop 2 stars, don't they tend to be smaller stars? Like,
well, they tend to be more even. They tend to have basically mostly hydrogen and helium in their cores and in their envelopes. Maybe some lithium. But the fact of the matter is, you know, those stars came, as you said, before the interstellar medium was enriched by all the many supernovae that created more elements that new stars were made out of. You know, and just because the sun has magnesium and calcium in its spectrum doesn't mean that those elements were made there. They were not. The sun can't make calcium. The sun can't make magnesium. You know, these were elements that were made in the hearts of other stars, but when the sun formed, these were in the solar nebula from which the sun formed, and so they ended up in the atmosphere of the star. So that's why we have those there.
Mark, not to digress, but you might have seen in the news or science news recently, they talked about finally discovering, what was it, helium hydride? They said that should have been like the first element or the first compound, whatever, formed soon after the Big Bang. Did you see that about helium hydride?
I did not, actually.
Oh, okay. Well, I don't mean to steer away from the show. I'll try to
No, that's fine. That's fine. I think you don't ever feel you can't say anything like that, Daryl. That's all good stuff. Okay. Just because I didn't see it doesn't mean I don't want to talk about it.
I'll try to send you something about it.
Okay.
Get you up to speed.
Thanks. Because I have not seen it.
Speaking of seeing things,
yeah.
Abducted wants to know if we can see Canis Major dwarf galaxy.
Oh, I wish, but Canis Major has set, unfortunately.
Next time, come here early and ask us early on, and we'll see what we can do.
Yeah.
Mark, that reminds me of something else. We looked at the Eskimo Nebula recently.
Oh, yes.
One of your last streams. Is it out of sight now? Is it too late in the season?
Oh.
It's in Gemini, isn't it?
Yeah.
I might enjoy it.
I wish that we both, Daryl and I, wish that you were here for us with us when we saw that, Amanda.
Yeah,
yep.
I know. I heard.
It was just beautiful.
That was excellent. Is it too late in the season to see it now, or would you have to move the dome? Or
I might have moved the dome, but that's worth moving if I can find it. See if I can get to it. There's Procyon. It's still up. There's Gemini over there.
I see that.
Yeah.
Hi, Pollux. Hi, Castor.
Yeah, but wasn't it? I think it's down there somewhere. That's actually. Oh yeah, that's in the west. That's where my house is right there. My house comes up. I should make a new landscape that includes my house. I can do that on Stellarium. I can put my own landscape in. But I don't. Let me see. Is this it? Yeah, that's it. Let's see how high it is above the horizon. It's only going to be about 24 degrees, 23.5 degrees above the horizon. And it's really, yeah, that's going to be down. That's probably directly behind the house right now.
Okay. Well, you'll have to wait then, Amanda, till this fall.
Or actually until the
Aw.
next night, and we catch it before it goes down, because right now we're several hours in after sunset.
This is true.
Yeah. So let's see now. Coming back to where we are. We have this guy. Okay. This is the ghost of Jupiter. This we've seen. And it's in the southwest, so it hasn't even set yet, but it is kind of low in the sky. We have one really low here, and that's the gotta try and get that in here so I can tell you what it is. There's a star that's right next to it. It's hard to catch it. Let's just zoom in. There we go. NGC 2610, yeah.
Planetary.
Yeah. But again, that's very, very low. Alright, so.
People are getting a bit of buffering,
Yes?
just to let you know.
Okay. Alright, there's Spike and Sombrero. It's kind of low, and it's going to have. Those are going to be in the clouds anyway right now. We just looked up there, and the scope's right there. We just looked at M3. And this is Booties over there. I really would like to see some of the
Corona Borealis right there.
yeah. Yep. See.
Northern Crown.
Yep.
And Alphecca is also called Gemma or Gemma, which is the jewel in the crown.
Yep. Also known as Nosha and Astaroth. Just they can't make up their mind. I know Amanda likes the mythology things when we bring it up, so I'd like to bring those up now and then.
Sorry, the music's a little loud now.
Yeah, it is, isn't it?
That's the head of Draco right there, the dragon.
Yep. Serpents.
Oh, excuse me. Okay, yeah, God, I'm sorry, I'm a mile off. That's,
Yeah, you're about 100 degrees away.
Yeah,
That's okay.
Sorry. Yeah, serpent's kaput. That's the head of the serpent, and there's Ophiuchus holding him.
Yep,
the
that's right.
There. Yeah.
Yeah. And then here is the Blue Horsehead Nebula, which we can't see because it's down where there's a cloud. I know. I just saw it earlier. Okay, so I guess what we're going to have to do is I want to stay up high in the sky. Let's try one other thing. Unless you have any requests, Daryl, I'm going to
Go for it.
Okay, I'm going to take us...
Abducted wants to know if we can see our binary star system. Not sure which one they're referring to.
Well, there's a lot of them, and I think that, we should be able to.
Saying our, I don't know.
Yeah, we don't
have a specific one in mind. I don't know.
We're not in a binary star system ourselves. But you know what I'm going to do? I'm going to take us to the Siamese twin galaxies, so we can see these two. And these are very interesting galaxies, actually, to take a look at.
Folks, I'll be right back.
Okie doke. Yeah, if you're seeing
A few
buffering,
people were.
try to
Yeah, a few people are buffering.
just try and do a refresh if you could.
It's bad.
Okay. I'm just sort of letting things calm down here. I'm doing fine in terms of the stream, so I don't see anything going wrong at my end. But it doesn't mean it's not. I'm just saying, you know. Okay, so now let's try 15 seconds at, let's do 16,000, or, you know, yeah. And now we can see if we'll see the Siamese twin galaxies here.
The conjoined twins.
Yeah. I remember we looked at these once before.
Mhm.
They're really cool.
You remember that lame joke?
I do. It's the lame joke you made.
Yes.
Yes, exactly. It's alright. Yeah, here we go. Look at that. So here are the Siamese twin galaxies. Why are they called that? Well, because they are right near each other like this in space. You can see their bright nuclei, and you can see that they're almost touching each other, it appears. And there's another one up here. There's another galaxy up here. See that? So let's see the details about the Siamese twin galaxies, and then we'll come back and check it out. So they're also called the fish and chips galaxies.
I don't remember that from last time.
Yeah, that was.
Oh, yes, I do.
Yes.
Yes, I do.
Yeah.
I didn't know that that was the Siamese, though.
Yeah, but here's the thing. These are literally a tenth of a billion light years away. These are 105 million light years away. Okay. Okay, so they are quite distant. All right. Now you'll notice here in our view here, you'll notice how they're going across the sky, and it looks like we're seeing these lines move. That is moving. What's happening is we're tracking the Siamese twin galaxies. We're tracking them, all right, with the telescope. And so as the Earth is rotating, if we didn't track them, then they would rotate out from under us, you see, like this, as they're doing now. But we're tracking them. So because we're tracking them, okay, we're staying with them. So the telescope is very slowly moving and following them around as well, which is actually kind of a very interesting thing here for us to do. So that's the actual mechanics of what's going on here as we're studying and learning about the night sky. Okay, so our camera and telescope are following the stars like that. We see some actually nice detail in here. Okay, that's pretty good. Yeah, Siamese twin galaxies, Daryl.
Thank you.
The fish and chips galaxies.
Yep.
All right.
Okay, good.
I never did.
Abducted.
I'm sorry. Pardon me.
Yeah.
What were you going to say?
Oh, I was going to say I never did get that darn fish sandwich before Easter.
Aw.
Well, it's the fish and chips that you were looking for, right, Daryl?
Sure.
Yes.
Chat always has a tendency to make people hungry. I apologize.
What? Why?
Because we have the hamburger galaxy, the fish
Oh,
and
yeah.
chip galaxy.
Well, that's astronomy. I mean, think about the people that named them. You know, they had to be hungry. You know, it's like, man, I wish we had like a hamburger. Hey, this looks like a hamburger. We're gonna call it the Hamburger Galaxy. Oh, all right. You know. All
People
right.
craving midnight snacks while they're
I
looking
know.
for galaxies.
I know.
Been there, done that.
Ah, yes.
That's where a box of Cheetos comes in handy, but you have to keep your hands clean when you're around the telescope.
Yes, exactly so. Okay. Now we're gonna go to Messier 60. Okay. And this is an elliptical galaxy. That is to say, a galaxy kind of like M87, but it's brighter because it's, I think, closer Let me see that I'm saying that correctly. Yeah, it's just a little bit closer. It's 54 million light years away. All right. So it's So let's that's not it there. This is where we gotta be. So let's just go eastward a little bit and jog it westward a little bit once we get there. Bam. Okay. Now let's do 15 seconds at 16,000 and look for these two galaxies. And what two galaxies? Well, these two, the ones I'm just about to show you. We're looking for M60 here, and we're looking for NGC 4647. And that is an active galaxy that is in proximity to this one, visually, but in reality is much further away. This one is 79 million light years away. This one is 54 million light years away. So this one here is 20 million light years further away, more than 20 million light years further away. Isn't that crazy? However, in our image here, there they are. And I had a little glitch with the telescope apparently. This shows it well though. Okay, and I'm gonna come back to that. There's another one down here actually that you can just barely see. Let's do that one again. Do that galaxy again. All right, do that image again, I should say. And we'll do another 15 seconds. Yes. Okay, so let's see how this one looks. And here it comes. That's much better. Oh yeah. Now you notice, very interesting here. Now we're doing this at 16,000 ISO. I think, if I don't miss my guess, I think we actually have some clouds here. That's why we're looking at a little bit of a color shift here. But here, these are two galaxies. That's an active galaxy right there. You notice it's distinctly different in color than this one. Okay, this is farther away. Okay, now it also means that because it's farther away by 20 million light years plus, okay, its light is going to be more red shifted. Now that doesn't mean that's why it's looking red. It just means that its light is going to be dimmer basically, and we can get from it a parameter that will tell us from its something called its redshift. We could find out how far away it is, and then we have this galaxy here, this elliptical galaxy. We also have another one right here. We have another one right here. If you notice, it seems like galaxies are omnipresent. They're everywhere we look almost. And it's actually true. They're almost everywhere we look. Isn't that incredible? Look at these two little stars down there. And that's those two little tiny stars that no one would ever notice unless we brought them up in SkyTour LiveStream right here. Those two little tiny stars. Are they binary? Who knows? You know?
Let's go investigate.
Yeah, right?
They could just be a line of sight like the two galaxies are.
Yep, that's correct. And well, the reason I bring it up is because these two stars are placed about at the same angle as these two galaxies. And these two stars might have a similar distance difference between them. That is to say, this might be a star that's a few hundred light years, and the one could be next to it could be 1,000 or more light years for all we know. I don't know. But these are two elliptical galaxies, active galaxies here, and this elliptical galaxy there. Elliptical galaxies always look like little fuzzy spots like this. And this is a very nice galaxy. And I just thought that was pretty to look at tonight.
M60, right?
Yes.
Yeah, what constellation are we in?
I believe we are in... let me just make sure I know where we are. We are...
Okay, you're still in Virgo.
Yeah, I think so.
I was gonna guess Virgo.
Yeah. 'Cause
Yeah,
there-
no, we're
there-
still in Virgo. Yeah.
There she is, right there.
Yep. Very
Right
good.
up in the cluster.
Mm-hmm. Yes, that's beautiful. Oh, yeah.
I
So,
don't know why I was gonna guess Virgo, but I was.
well, we were hanging out in Virgo. It was a fair guess. I'll give it to
no,
you.
we went from Gemini to Siamese.
Yeah,
That's
but we
true.
didn't. We
I
didn't.
had twins on my mind.
That's true.
Siamese fish and chips.
Yeah.
Yes.
What is it called? The Siamese cluster?
Siamese. It was a Siamese galaxy.
Twin galaxies.
Yeah.
Siamese twins galaxies.
Siamese twins. Yep. Shall we go look at M90?
Why not?
Let's.
Okay. Indubitably. Oh, let's go. After you. Why, thank you, sir. After you. Oh, no, I insist. Remember Chip and Dale?
Oh yeah.
That wasn't them though.
No, because I can't do them anymore. When my voice had that, when I lost a vocal cord, I lost probably 70 of the 80 character impressions that I do.
No, I don't mean your impression was bad. I mean
It was bad, though. It was. But
it wasn't Chip and Dale though. There were two gophers or something, and they were extremely polite to each other.
Yeah, that's correct. That was what I was
But
talking
it
about.
wasn't Chip and Dale though.
It wasn't Chip and Dale?
They were chipmunks, weren't they?
I don't think so.
I think they were.
If they were, they weren't Chip and Dale. I thought they were gophers or something.
Yeah, but I thought the gophers were named Chip and Dale.
No,
Yeah,
Chip-
and I thought
Chip and Dale.
it was Chip
Who
or
lived in a
chipmunk.
tree. These guys lived underground. Help me
Like
out,
Chip-
chat.
Like chipmunks do. That's why they called him Chip.
It's okay.
Chip and Dale were chipmunks. These two weren't Chip and Dale, and they weren't chipmunks. But they were very polite, and I know the characters you mean.
Yes. After you. Okay, yes, of course, after you. Oh, no, I insist. Okay, thank you very much. Of course.
Anyway,
Hey,
there's a
Keisha.
question I missed because we
Keisha
were...
Fowler's here. John McKechnie's here. Hey, John. Good to see you.
I know. Hi, Keisha.
Oh, there's M90. Look at that. M90.
Do wants to know, isn't there a dark area where there are no galaxies?
Oh, yeah. Isn't that in Booties? In Booties?
Yes.
The Void.
The void in Booties.
Yeah. Yeah, the Void is a location where, for whatever reason, there's just not a lot of galaxies. Which is kind of interesting. I can't explain why there's a void. Nobody really can, but I do know that the universe did not form in a homogeneous manner. That is to say, evenly in all directions. So I suspect that it's probable that such a void is to be expected here and there. Just like there's areas in the many filaments that connect vast superclusters of galaxies where there's no filamentary structure at all. So it's pretty impressive. It's impressive about what we learned.
You might remember when they shot the Hubble deep field, the ultra deep field. They pointed that at an apparently empty piece of sky.
Oh yes.
And if you have a big enough telescope, you let your exposure run long enough. Well, guess what you find? There's galaxies everywhere.
That's right. And Keisha, I'm glad you heard me say hi to you. Thank you. Hi back to you again. I'm glad you guys joined us. It's so nice of you to come along for the ride. We've had a good time tonight. Clouds are moving in, unfortunately, and so I hate that fact. Unfortunately, it's gonna monkey with our night. Darn it all! I just don't like that. This is Measure 90 that we're looking at. What's Measure 90? Well, it's this right here. Okay, it's this this galaxy right here. It's actually a very tightly wound spiral star, a spiral galaxy. I mean, that's what we're trying to see. That's what it's supposed to look like to us. And in our view here, we can see that we're getting some of that. And we actually have, believe it or not, a little bit more detail in our Measure 90 than the Stellarium view has.
Can I just
You may.
throw something in here?
Yes?
The Goofy Gophers, Macintosh.
No, I don't have any idea who those are. Never heard of them.
Never heard of them. Never heard.
Heard of Chip and Dale, though, the very polite gophers.
Chip and Dale were chipmunks.
Or chipmunks, I
The
mean.
Goofy Gophers are an animated cartoon character in Warner Brothers Looney Tunes and Merry Melodies.
Oh, yeah, no.
Their names are Mac and Tosh, and
No.
are small and brown with tan bellies and buck teeth. They both have British accents. The names are puns on the surname Macintosh. They're characterized by normally high levels of politeness.
But that was Chip and Dale.
Thank you. Thank you. No. Okay, you went back to the stars, back to the galaxies.
Now that rings a bell. Whichever ones were so polite.
Yes.
It
they
always
were
reminded
gophers.
me of a couple of French characters, Alphonse and Gaston.
Oh, yeah.
After you, my dear Alphonse. No, no, I insist, my dear Gaston. After you.
I do remember that. Alright, now we're going to go to this galaxy. We should actually see several galaxies here. Alright. And
And Karen, I used to do an awesome Roger Rabbit impression. That was Mark, not me.
how do you know? I think it was you.
Maybe it was Daryl.
No, it was me.
Amanda, let me hear you say, I'm not bad. I'm just drawn that way.
Ooh, that's Jessica. I can't do an impression of her in any way, shape, or form.
Hey, that was
I
very good.
did. You can. I'm not bad. I'm just drawn that way.
How did she say it? She said it all innocently, though. It was a plea. It was, I'm not bad. I'm just drawn that way.
Right.
Very good.
I can't do a Jessica Rabbit impression. I never claimed I could. I can't even do Roger anymore. I used to. Please, Eddie. I can't do it anymore.
Please. You gotta shake your
It's also
head.
like 20 to 1 in the morning. Maybe the impressions will come out later on. Mark's good at impressions. He doesn't mind being silly.
Oh, I don't mind being silly, of course, because, you know, if you can't laugh at yourself, then who do you laugh at and not get in trouble?
You.
Exactly. Okay, this is a beautiful galaxy right here. Look at that. I've got to also turn off.
Mark, do you think the clouds may be affecting your transparency now?
Yeah.
Remember, we had such a clear night earlier.
I do, and I'm trying to figure out. Okay, we got something there going on, so I got to get rid of that. And let's check this out again.
Karen wants to know if you can explain dark matter or voids, if they exist.
Well, the dark matter thing might be a thing of the past, and that's something that still remains to be seen. But we may have accounted for the matter that had caused us to postulate the question of whether there was actually other matter in the universe that we didn't see.
So the dark matter was just a name as a holding spot for the missing pieces of space that we couldn't account for, the missing matter in space?
Essentially correct.
But now we think we know what it is, where it is.
We think that we
why
may.
it isn't around.
We think we may
how do
know.
we-
We think we might know what's going on and whether there's actually dark matter at all. And the reason comes down to a couple of things, namely that when we looked at the voids between the galaxies, thanks to the fast radio bursts that came in that you and I did a radio show on at SkyTour Radio, we actually could see that there was stuff between galaxies we did not account for. In fact, there's lots of material between galaxies. And it might be that this is the matter, the missing matter. When you look at it and add it all up and kind of do a statistical analysis to figure out where all this matter is and how much there is, it might actually be that there's matter enough to be available to have made the Big Bang. Because it was otherwise we were looking at this missing matter. And since there wasn't enough matter, that also brought up other postulates that said, well, maybe we're just a small universe that was spawned off of other universes in a parallel universe situation. Now, keep in mind, that could still be true. That could still be true. But we're looking now at a possibility of the fact that the dark matter may not actually exist. We may have enough to have caused the Big Bang that we see, but again, it doesn't mean that the parallel universe theory is gone. I personally believe it's not. Okay. I'm going to make a comment about this galaxy here, by the way. Let's go back and look. Okay, we are in what's called the blow dryer galaxy, of course. Give it a name. It's a M100. Okay, Messier 100. And the thing about Messier 100 is there are these very faint stars, and you see them? And these stars are... they could be field stars in our own galaxy, but I want to show you something about them that makes me wonder whether we're not looking at maybe something like other globular clusters in another galaxy, because we can see them. We can see globular clusters very brightly. This galaxy, though, is pretty far away. It's 54 million light years away. All right, but if you notice these little tiny dots, okay, these little tiny dots, you see them? And I think that these little tiny dots could very well be something in this galaxy that we're looking at here. So let's do a little processing so you see what I mean. So if we zoom in, okay, look at there's these little tiny dots, right? These little tiny things. And we don't really see any... What's that, Daryl?
Not just foreground galaxies?
Foreground stars, you mean?
No, foreground stars, yeah.
Well, no, yes, I said they could be field stars, but I'd actually want to look at this galaxy in detail and see if maybe they did a study to figure out whether these are foreground stars or whether they're actually large areas in this galaxy that may be H2 regions, compact H2 regions in this galaxy or something like that. You know, stellar nurseries and so forth.
Right.
I'd be really interested to see that. So we're going to look at that at some point, and we're going to go through that when we know more. And now let's see. Let's go down to this galaxy right here. This is the Virgo Pinwheel. This is a beautiful galaxy. We're going to check it out. If it feels like I'm rushing, it's only because I know the clouds are coming. Looking out the window, I know that we're going to be struggling here shortly, and I don't want to be struggling too bad.
Another M object too, M99, I think.
The Virgo Pinwheel, yes. Confirm that. It is M99. Okay, so let's go over here, run eastward a little bit. Okay, bring it eastward a little bit, and stop. And
Are we trying to outrun the clouds? So we're going east.
No, it's just the telescope alignment is such that I have to go eastward to bring it in, and then I have to go. I have to then take us west a little bit with a little west jog, just to account for what's called backlash in the telescope system. 15 seconds at 16,000 on this guy, the Virgo Cluster Pinwheel M99. And we shall see it momentarily. It's fun exploring the galaxies in the universe.
Mark, do you think jogging the backlash like that has helped the scope? Or helped your imaging?
Oh, well, certainly. It stopped, you know. If you notice, we have had very few times tonight where when I would image, it was streaky. You know, we didn't have any. We had maybe one of those.
Right.
and not a whole lot of other times when that's happened. It's happened in the past for those that listen and watch. They've watched this happen. We've actually had to take like 3 or 4 shots in a row because the telescope backlash had not been corrected. But now that I just do a west jog every time I go somewhere, we're fine. I'd like to actually program that into the scope automatically, so when I'm moving somewhere, it automatically does the jog for me. So that would.
I imagine I imagine a periodic error correction would do that.
Yeah.
Of course, you have to train the telescope.
Yeah, which I'm happy to do with the summer coming.
Right.
I never did the PEC. That's called PEC, periodic error correction, folks. I've never done the PEC training on the telescope before. That's beautiful. Look at that. You can actually see the pinwheel pretty clearly. You might want to. Maybe I can actually. Let's see if this helps. Not much. Let's try this. What if I do this? That's interesting. So that's the processing, some immediate processing, and we don't do it. It looks like this. So it kind of is washed out a little bit. Here we can actually see the structure a little bit more clearly. I think it's pretty nice.
It is.
Yeah. Okay, so now on our ever increasing quest, and by the way, if we end up doing the Measure Marathon like Amanda wants to do, we would probably be running around like mad, going from object to object very, very quickly.
I think it would be fun.
It would be fun.
I think people would really enjoy it.
I'm all for it. It's just that, we wouldn't be sticking around any one object very long. That's the only problem.
Well,
That's okay. I don't mind. As long as they don't mind.
Probably be too busy to talk about Jessica Rabbit too.
That's right.
But hey, there goes the fun in it.
Yes, exactly so.
how many messier objects are there? 117?
110,
110?
I do believe.
We could find out the name. Well, you guys already know, but I can find out the names of them all, and we could have like a little joke or impression lined up for each of them.
Well, that's
Good idea.
some of them don't have names at all. They don't have like names. They're just open cluster in Cassiopeia, like M103. Well, what else is there? There's nothing to say.
Well, that's when you insert a joke.
Yeah. All right, this is now a picture taken of M98. This is right here. Okay, and let's go see M98.
Looks like we're in Coma Berenices now. Finally climbed up out of Virgo.
Look at that. Yeah, look at that, huh?
But isn't
Yes.
I thought we talked about this once before.
We
Isn't
got clouds here.
Bernice's
Hair.
comb and hair? Isn't that still in Virgo? Didn't
No,
I
no,
suggest
no.
that maybe Bernice was Virgo? Maybe that was her name.
You did suggest that, but no, it's not the case. Bernice Berenice, she was somebody else. She gave her hair
Oh
as
yeah.
a sacrifice, as an offering for I think the return of her husband from battle, if I remember correctly. And Coma Berenice is a constellation all its own. It sits a little above and between Virgo and Leo. And Coma Berenice is on that band I mentioned earlier tonight, where all the 3/4 of the 1,000 brightest galaxies are, from Ursa Major down through Canis Venatici and Coma Berenice down to Virgo and Leo.
Got that, Amanda?
Hmm. I remember that.
Okay. All right. So, in looking at this galaxy
Well,
here.
darn it, make a liar out of me. That said coma, didn't it? Because that says we're still right in the middle of the Virgo cluster.
Yeah, we are.
Okay. Well, my bad. I'm sorry. I thought it said coma.
Oh, sorry. No, remember
You're
to be,
getting up there, though. There's Dead Ebola and Leo and Virgo to the lower left, so you are kind of heading up into coma.
yeah, I mean, we could get up, a little higher. Like maybe check out the Black Eye Galaxy.
Sure.
Okay.
And 4565 is always.
Yeah, where's 4565 relative to the Black Eye?
I don't remember, but they're both. I think they're both in coma.
Okay. Well, let's check it out. Let's see if we can go here and check it out. Shall we? Shall we? Yes, we shall. All right.
Well, here's-
And off we go. We're moving. I saw that I had a little bit of what looked like clouds, obviously, on the last image here. So we're gonna have to do an evaluation, run outside and check it out. But first, let's do a picture. Okay, go east a little bit. Kick it left. Okay. And now let's do 15 seconds at 16,000 once again and see what we get.
I suppose down the road when you get your roll-off roof observatory done and everything, and you're settled down in Arizona,
Yeah.
or if you're doing it remote to Arizona,
Yeah.
you'll have an all-sky camera too, just so you can check sky conditions.
Yeah, I'm already planning on all sky as well. Now there's the Black Eye Galaxy.
Well,
Now this is a really pretty galaxy, and you're seeing this very prominent black dust lane really close to the nucleus in this galaxy. Now there's another one out here that you can see, and then a couple more out here on the outer fringe. And the Black Eye Galaxy has always been a favorite of people who want to see that particular object in the telescope, because it's actually pretty visible in the telescope. You can't miss it, actually. It's pretty cool. And I just brightened the image just a little bit so you can actually see a little more detail. So you can see there's some dark lanes this side. In fact, there's like a sort of a number of these little striated lines over here, which exist. Same thing on this side. And we have that prominent one that's over there. But man, this is beautiful tonight. This is a gorgeous view. It's an absolutely gorgeous view. And there's a extreme close-up with the noise. Okay, that's actually what it looks like with the noise.
sure can see it well, though.
Yeah.
It's beautiful.
Yeah, I would love.
Looks like an angry eye.
It does, doesn't it? Yeah, but you see, we are seeing a little green here, a little red. This is definitely a cloud. But even so, still see it.
So you said the black over top of it is dust? The black lane is dust?
Yes.
Yeah.
It's a dark dust lane, and you can see more dust lanes here, and you can see the complexity of the dust over here and this edge. This is a well-known area in this particular galaxy where that dust has got that kind of look to it. It's amazing.
Is that basically true of most things we see? If we see dark lanes, am I right to assume it's usually dust, or what else could it be?
Yes.
If not dust, it's usually dust, right?
Yes, it is.
Dark lanes and things. Okay.
It can't be gas because gas is not colored usually. I gotta be careful because, like if you see.
See, I don't want to say anything with absolute certainty, because there's always an exception, right? But
Yeah. I mean, the gas, if it's carrying something in it, like nitric acid, okay, or bromine, it looks brown, and it has like a brown haze to it. But you're actually looking at a solid, particulates in the gas, in the material when it's coming off things. So it makes this brownish, haze in the air. So imagine a lot of it would tend to look like a cloud, for sure. But like I said, in general, when you look out in the universe, whenever you see something dark in the galaxy, you are certainly looking at just dust. And we're looking at micron-sized particles of dust out in a galaxy like this, or out in our own galaxy. And that's kind of what this is. Really, very, very interesting. I'm going to run out and check on the cloud situation, because I'm noticing that we have clouds in this image even still. But even the image looks pretty good, but still I'm noticing clouds. So while I have this image up, I'd like to go out and just check on the situation. So do you mind if I run out and do that?
go ahead.
All right, Daryl, you all set?
Oh yeah.
Okay. Speak amongst yourselves. Go to the bar, have a drink. I shall return momentarily. All right, be right back.
Amanda, you might remember when we looked at like the Hamburger Galaxy and the Sombrero Galaxy earlier tonight, and when we looked at NGC 4565 before, that we see the dark lanes across all of those galaxies. Well, when you see like the Sombrero, and more so in the case of the NGC 4565, that's the one that's edge on, very thin, looks like a needle. We're looking at this galaxy at a little bit more of an angle, so we see the black eye there a little farther up from the center of the galaxy. It's tilted to our point of view. Maybe before we run out of sky tonight, we might get a look at it, see 4565. And I have an idea where it is when he goes back to Stellarium. We'll see if I'm right or wrong. And also, everybody, if you're lucky enough to be able to go out and see the Milky Way, as it should be seen, where you see it right across the sky, you'll see dark lanes along the arm of the Milky Way. And that's the very same thing again. You're seeing dark clouds of dust intervening between us and the stars behind them. You look down between Cygnus and Sagittarius, you'll see a big dark line. Nice music.
I wish you had turned it down before you left. You were cutting out a tiny little bit during the. I heard most of it. It was just cutting out a little bit. I don't know if I am too.
I'm sorry. No, you sound fine.
Yeah. Karen wants to know what else is there in space and what is dust. Good questions.
Dust is elements or compounds formed during the operation of stars. There's a lot of carbon, probably silica, aluminum, you name it. Whatever old material. It's the same stuff that the sun flew through and gathered when it formed. It was mostly hydrogen and helium, but there was also other elements from earlier generations of stars out in those dust clouds where the sun formed.
You're calling those elements dust? No. The byproduct of the creation of them?
The creation of them themselves, yeah, they're dust, basically. Little particles of dust, and sometimes they start collecting, and then they start building, little clumps, and get enough clumps, and you got an asteroid or a planet or a star.
Well, yeah, but hold on, that doesn't work the same with, like, dust around your house, so what? Explain that, because I I never really thought that much into it until I saw that question, and that's a darn good question that I probably should have come up with, I don't know, last year sometime.
Well, look at it this way: is the dust in the dust bunnies under your bed really any different than the dust out in space?
I don't know, are they?
Yes.
Okay.
Well, that's what I figured. Welcome back, Mark. Good
No,
segue there.
that's okay.
Listen,
I was just
we were
listening
trying
to you. I was
trying
listening to your
explain what is
discussion.
dust.
Yeah, it's the interstellar dust is interesting. It does a lot of it does originate in supernovae as well, and some of it is kind of like Daryl said, there was some carbon elements within in dust. There's also different types of dust. It's usually just a few, it's like literally 0.1 micrometers. It's tiny stuff. It's like submicron sized particles. But depending on how they were formed out in space, they could be kind of spindly and be polarized in a way, so that they could act like polarizers too. And so there's a lot of weird notions out there about what this dust is. But much of it comes from exploded supernovae that blew off their outer envelopes, so forth. And so.
But are they fragments of elements that aren't anything?
No, they're molecular in nature in many cases, actually. They're dust. So when we say dust, we're talking about lots and lots of atoms. We're not talking about singular atoms, because then it's just singular atoms. Okay, this is something. They're dust grains. They're pretty complex. Okay, and they will
Can all that dust recombine to make a star?
It'll get swept up into a star that's forming, sure. And when it does, it'll be in the star's envelope on the outside, and perhaps be destroyed by the plasma in the star, and most likely will be once the star winks on, so to speak, and starts hydrogen fusion. But we see this dust in space usually with the infrared. Infrared telescopes show it very well, because the dust grains will heat up, and once it heats up, then it will radiate. The only thing that happens, there's no such thing as temperature when you're talking about objects in space. It's only absorption of radiation and radiation itself, the radiating of radiation. So things either absorb or radiate. They don't have a temperature, so to speak. So we characterize how things radiate in space by their black body temperature. That is the temperature that a perfectly black body would radiate energy at. Stars are actually very close to being these black body radiators that will give off their energy in this way. Many of our laws within physics and astronomy are based on black body radiation. Things like that. So, for instance, Wien's law, W-I-E-N-S, Wien's law talks about the maximum frequency of the light we get from a star, and it's based on the star's temperature, right? But we characterize the star as a black body, a perfect black body radiator, in order to figure that out. All right, and so that's kind of how that works. So it's sort of an interesting little caveat. But keep in mind that this whole concept of dust grains in the universe. Okay, dust grains are created in a variety of ways. Now, if you have a shock front of gas moving out from a supernova, and it impacts a bunch of atoms that were previously released by a supernova, well, then they could be compressed and squeezed into other objects and become more objects, become thicker, heavier molecules of other material. And we might actually have to do a SkyTour radio story, and actually not just story, but maybe a whole show for all we know, on just what is out in the universe. What do we have in the universe? What's out there? Besides the stars, besides the galaxies, what is the rest of the stuff that the universe is made of? And we might actually call it,
Cosmic dust bunnies.
yeah, right. It's funny, cosmic dust bunnies. Or say like, what's the stuff of the universe? In quotes, what's the stuff, quote unquote, that makes up the universe?
If you consider when we've looked at M16 before in Serpent,
Yes.
The Pillars of Creation, the famous Hubble picture, you're seeing nascent stars being formed inside dust clouds.
That's correct.
And sometimes we get to see them blowing the dust away from the star.
That's right.
And that's exactly what we see in the Pillars of Creation. And
in the Orion Nebula.
See much the same thing in like M42 and Orion.
Yeah,
also.
that's right. In the Great Orion Nebula, we see the same thing. Yep, that's exactly right.
Yep.
Yeah, you have spoken wisely. Yeah. Yeah, see, so...
I still want to get back to this dust, but
okay, go ahead.
David had a question.
Okay.
David wants to know, have any of our flights collected samples of space dust and atmosphere? Atmosphere being in quotations.
From asteroids, yes, they have.
Japanese
are doing it right now.
Yes.
Nice.
Hayabusa 2, actually, didn't they just land on, is it Ryugu?
I believe so,
And
yes.
they were sampling, they successfully grabbed...
Is that an asteroid?
Yes.
Yeah.
Ryugu. Ryugu. And they actually landed there, and they grabbed a sample that they're going to bring back to the Earth. But they also detonated a large explosion on the asteroid to check out how it's made and to get information about how it's made. I hope there's nothing living there, that we don't understand in the universe, because then they would take that as an attack. I think it's really funny, but I don't think it'll happen. So...
There have been one or two other attempts to capture asteroid dust also, I believe. I forget how successful they were. I think the Japanese did another one. I think we did at least one.
Mm-hmm.
I want to say ours might have had questionable results. Or they did catch a little bit or something, but might not have fulfilled their main mission.
Maybe, huh?
I forget.
Okay. I don't remember.
The mission Hayabusa 2, the Japanese one we're talking about, they have some pretty darn cool video. The A, when Hayabusa touched down on the asteroid the first time, and I don't think it was when they fired the projectile into the asteroid, but boy, they sure blew a lot of junk off the surface of the asteroid. I mean, it looked like breaking glass flying all over the place. And then when they did fire the projectile, that really blew up a lot of junk.
Yeah, that's the thing about the thing is, the asteroids are tricky because, are they solid? Some are, but some of the smaller ones, like Ryugu, these could just be basically gravel piles of gravel that are mutually, brought together by their own mutual gravity.
Right.
And gravel pile asteroids could really be, pretty dangerous to play with because, you hit them and that stuff flies off, and because they're so small, that stuff flying off has already reached its escape velocity and can certainly get off of there, you know what I mean? And leave the asteroid behind.
Yeah.
And that's definitely not a good thing. At least it...
Karen's still asking about void and dark matter.
Oh, we didn't mention...
Is there more void than dark matter? Because...
Well, see, this...
you were saying it might be a thing in the past, we might have solved it. What is void, though?
Well,
is that not the same thing?
A void is typically an area that has a lack of material in it. And what we found is that
How
there's,
often do they come up?
well, that's the thing. We don't really see too many voids. There is the void in the constellation of Bodes, and that's a void where there doesn't seem to be much of anything. And frankly, to be honest with you, Bodes was just like one of my most unfavorite constellations of the year. You know, which is kind of sad but true. You know, it's been sort of one of my non-favorites. By the way, just so everybody knows, I'm not wasting time here. There really are clouds everywhere out there, so we're kind of stuck. And I'll hang around for a little while and see what we can get, but I don't know that it's going to get any better, frankly. And I apologize for that. So meanwhile, why don't we take a look at something like the Eagle Nebula right here. This is one of our shots we took within SkyTour LiveStream. This was a beautiful photo. And when Daryl was talking about the pillars of creation, he was talking about this area right here. These are the pillars, the things that the Hubble telescope took a picture of.
Now, can anyone else see it, or is it just me? Right there where you have highlighted, where that box is.
Yes.
Does that not look like someone, like, holding their hands out in prayer, looking down?
Whoa.
An alien praying, maybe. I don't see a person.
Is this the head?
That's the head, yeah.
Yeah.
And then the dark...
And these are this is like a
dark,
thumb
that's the
and a hand.
hands,
Yeah,
and
okay.
then you go down to the elbow, and then it goes back up towards the shoulders and everything.
Okay, well,
And the dark is the shoulder and arm going up, and...
And
like where the bright star is, would be like the neck and chin.
or the amulet to worship the sun god Ra. Yeah.
Maybe.
I get
And
it.
then the rest fades out to the body, and then, I don't know. I always see a person praying.
No, Daryl, I'm not hanging up on Amanda. No, I'm not going to do it.
No, I'm sorry. I'm trying to think of a word. I'm having a brain lock here. It's the human tendency to see things.
Oh, pareidolia.
Oh, pareidolia,
Yeah,
yes.
thank you. Pareidolia, thank you.
Oh, I know that too. Don't just ask Mark.
Well, okay.
Excuse me.
Amanda, what you described, most people look at and they see an eagle. That's why they call it the Eagle Nebula.
Yeah, I don't see the eagle. But I don't know, pillars of creation makes me think religion, and
Okay, I see what you're saying. But
sometimes I see someone praying and I think like the big red swoosh behind it is like maybe wings for an angel.
like this?
Uh-huh.
Yeah, I don't know.
Like the red, like, well, because I'm seeing a distinct person in the middle, right? I know it's all red and it's all together, but
Yes. I've forgotten
yeah, I
how
wish
beautiful
I could
this image
control
was.
your mouse. I would outline the whole thing. Where your mouse is right now is the elbow. Just
Yeah.
shift.
I see what you're saying. Sure.
Yeah.
You're right here? Right there?
Pretty buff.
Yeah.
Pretty buff arm there too.
Yeah, really. That's like a Popeye arm.
Ooh, I've got Popeye arms. I got.
And the head and the neck looks sort of like a lizard man to me.
Yeah.
They're right there, and the dark spot's his eye.
Oh, yeah. That's the salamander fetus.
There you go.
Yeah, see a salamander fetus praying here.
Well,
With big
the
muscular
wing
arms.
star isn't part of, like Mark said, maybe it could be a necklace or something, but
I know what you mean.
that's not part of the picture for me.
Okay.
Anyway, that's what I see.
Yeah, I see a lizard head or a salamander head there with the
Yep.
dark spot's his eye, and
See that? Well, it is for a head.
you see
there's
his
a-
right shoulder and right elbow and right arm and hand.
Yep.
Yeah. I'm going to stop right there.
Yeah, I know. You should not go any lower now there, Daryl. Just leave it at that.
Yeah.
But that's pretty cool. Actually, and here are his legs. See, that's the right leg, and there's the left leg. See? You can make a whole
Well-
person out of it.
Okay. I see Godzilla now.
That's it.
Well, I was starting to see
Oh,
E.T.'s
no.
head with that big long neck.
There goes Tokyo. Go, go, Godzilla. Yeah.
Don't you see Godzilla now?
I do, right there.
Thanks, Amanda. It's all thanks to you.
It's Godzilla versus Mothra. Godzilla versus Megalon. Remember that?
Oh yeah.
Yeah. Yeah, they have these really funny names. So, yeah, so right now we're having fun, and these are some of the SkyTour LiveStream's past wonders that we checked out. And oh, sorry, did we gotta go back again? This is the overall.
No,
Oh, okay. Yeah, and I figured while we got our, clouds, this is the Gamma Cygni Nebula. This is the center star in the Northern Cross. And this is
the red one down in the right corner.
Yeah, and then this is the nebula. Yes, and this is the nebula around it. Dark nebula, of course, made of that dust that we talked about. All right, and then emission nebula here, which are what we call diffuse nebula, which also means stellar nursery. They're all kind of the same. Really, really pretty.
Yeah.
And
that
then
star's name is Satyr.
Yes.
If I remember correctly.
Yeah, that's right. This is the Lagoon Nebula.
Hold on, David has a question.
Okay.
It's just a general question, not about anything specific.
Sure. No, go ahead. Go ahead.
Well, it is specific, but not to your picture, I meant. A question about Hubble.
Okay.
When it first took the famous deep field shot, was it still in motion? And if so, how does it compensate for the movement to achieve such great resolution?
Well, the nice part is,
David, thank you.
Yeah, very good, David. The question is answered simply when you see just how far away it was actually taking this photo. The relative motion of the Hubble as it orbits the Earth was not anything that would stop the exposure because of the fact that the telescope is so far from this location in space where it's taking the picture that its motion left and right as it's going to the extreme edges of its orbit wouldn't even show up as the slightest error in the image. Now, if it was taking pictures, say, of the moon, well, then absolutely it would make a huge difference because the moon's a lot closer. All right. But even the nearest stars that it was taking images of, it wouldn't. That distance it moves over its orbit isn't enough to appreciably even show up as an error that we could even notice. So I hope
May I add something there?
You may.
Okay, David, the telescope is not only moving, it's going at 17,000 miles an hour or more while it's taking the image. The Hubble telescope does have an exquisite pointing system to keep the telescope locked on that exact place that's it's pointing toward as it takes images.
Yeah, and that's actually kind of a given too for any telescope that takes images like that. For instance, the Lunar Reconnaissance Orbiter. Now, ask that question there. That's a more meaningful question, David, because now you're talking about a satellite which is only about 60 miles above the moon, moving at an orbital speed to keep it in orbit around the moon. So it has some velocity, of course, and it can't sit still. So you have to say, well, it's acquiring this imagery. It has to be a very fast camera to capture this imagery, and part of that's probably true. I actually don't know the specs of the LRO camera, although I do know the scientist that actually created the camera for the Clementine Lunar Orbiter, and he had to actually capture images very, very quickly and in strips. He told me how he built that camera in the past, and I don't remember exactly what he did and how he did it, because he was doing it from just a electronic engineer's background, and telling us how he did it that way. And so I really wasn't, trying to retain that information. You ask me about astronomy, I'm okay, but when it comes to electrical engineering, I'm not the sharpest knife in the drawer when it comes to electrical engineering. I can tell you that. But I can understand it if I want to, but I probably didn't want to. But that's pretty cool. You know, either way. And so your questions are good ones. Very good. And that was I'm reading James Dugan had a question here. He's making a statement. Yeah, the shots are stacked. Yep. No, I'm sure that you're right. And the stacking process for the deep sky images like that, James, are going to be very different coming from the Hubble. But that's okay. They, in all, we're actually getting we're getting the same, reaching the same end. You know, trying to get a beautiful photograph. Okay, so let's take a look here.
Can I point out something in that image?
Yeah, this is the Lagoon Nebula. Go ahead.
Oh, I'm sorry. Boy, there must be a heck of a lag. I was over at the YouTube page for a second. I still see M16 there.
Oh, well, I moved to the Lagoon quite a while ago.
Yeah, I think because of all that buffering, people are lagging a bit.
Well,
Like,
make
I'm
sure-
seeing comments on things we said a lot longer than 30 seconds ago.
Yeah,
Well-
very good. I just hit the live button and I do see the Lagoon now.
Okay, yeah, folks, make sure you hit the live button to make sure you're caught up.
Sorry.
And Daryl, you can come over to Skype, pop out your chat, and watch on Mark's
I-
Skype.
Oh, I'm usually at Mark's page
Yeah.
or Mark's Skype, and I do see it.
Okay,
I thought he had gone back to M16 for a second there.
I
yeah, I
did
see
momentarily,
you
but that was
able to-
5 minutes ago.
Right.
Okay, did you want to
Exactly.
say something about M16 then?
No. Well, we might see the same sort of thing here, pertaining to what Amanda and the lady in chat was asking about dust.
Yes, for
and-
sure.
Well, heck, here Lagoon Nebula is a great place for that, I guess.
Yeah, it is.
You can see the dust and some of those stars right close to the dust columns. I dare say those are probably emerging from the dust clouds.
And probably so. This is a stellar nursery. It's a place where stars are being born, for sure. And you could see this dust here. This whole nebula is powered by a star right over here, in a little feature called the hourglass. We can't really see it too well here because of the fact that it's sort of hidden in here. But this is actually an O-type star, one of the hottest stars in the universe. And it's
You can
powered.
actually see the hourglass.
Yeah, right here we can, but we couldn't see it before when I was out there.
Uh-huh.
But I could zoom in now. So that's actually really that's actually part of what we're doing here. We're trying to show the hourglass, as well as the. I'm just trying to get this back down to where we can see. Okay, there we go. But you see this dust, as Daryl was saying. This dust here is stuff that is all part of this. The dust we've been talking about, the dust grains and so forth. So that's all here. This is what we're talking about.
I still need it explained more.
Okay, I'll have to show you.
Okay, so is it like a star that explodes creates the dust? Like, where does the dust come from? From stars?
You might say from earlier generations of stars.
Yeah, when
That
like-
have died?
yes,
Yes,
That have died.
Well, yeah, they're either old red giant stars that blew off their outer atmospheres.
Yep.
Slowly, they puffed them out, and all that dust and gas they puffed off, well, it went out into space and became new dust clouds. All
Okay,
the way up,
that's what I was missing.
yeah, and
Yep.
all the way up to supernovas exploding and blasting all their material, as Mark said, from the outer shells out into space, and
Yep.
it also coalesces into dust clouds.
yeah.
So
some of it
as-
does.
As stuff is going on inside the star, like, I guess, fusion maybe?
Fusion, definitely.
Okay, so while that's going on and it sloughs off the outer layers, that's creating dust.
Yeah.
Okay. Okay, that's the little part I was missing. I was trying to figure out where it was coming from. Okay.
Well,
And then it just goes off into space and
yeah.
recombines
You like planetary
That's
nebulas a lot. A planetary nebula is a perfect example of what we're talking about. That is an old, probably a red giant star that kind of slowly sloughed its outer atmosphere off, which forms into a ring or a torus or hourglass shape around it, and that's what the pretty planetary nebulas are made of.
That's right.
Like like the cat's eye, the help me here,
Dumbbell.
the app, the dumbbell. Thank you, the apple core nebula. I keep thinking of it.
the
The ring
whirlpool,
right there.
or the ring. That's what I meant.
Mhm.
That is exactly what is going on. That is blowing the dust back out into the local stellar neighborhood.
You know, dust as
And
well as the gas. I mean, right here we're looking. The things that are glowing are not the dust. That what we're seeing here is the ionized atoms of oxygen, which are in here. Okay, and these are just little bits of the hydrogen that are out here. Okay, and the central star inside of here, inside this beautiful nebula right there, this central star is actually the one that is responsible for making this entire nebula glow like this. It's got hot ultraviolet light, and it's causing the oxygen here to be doubly ionized. Okay, so it's pumped two electrons off the atom. All right, and so it's called oxygen 3, not oxygen 2. Yeah, go figure. Oxygen 1 is where it has all its electrons. Oxygen 3 is where it's been ionized twice. So that's, give it up for astronomers, making it confusing, right? And but this star here is a white dwarf. It's the remnant, but it's very, very hot and has very high ultraviolet content. So this is, I think it's about a light year across, and this star is so hot it can cause these atoms out here to ionize even that far out, right? And we can't see this in 3D. We can't really tell you how it looks in 3D, although we know from studies that it sort of has this that this is called a bipolar nebula. It doesn't mean it flies off the handle at a moment's notice. It means that it has a band of stuff that heads out this way and a band of stuff that heads out this way. Okay, and stuff around the sides is less dense. Okay, and we see a lot of this bipolarity in a lot of these planetary nebulae. That's actually a common thread. And studying the morphology of these nebulae has actually been something of an interest of mine. So that is this is an example of a bipolar nebula as well. And there's a lot of them, and we'll show you. You can't see them like in the cat's eye. It's pretty much spherical. It's a spherical envelope. And the one that we saw in Puppis in that open cluster, which is superimposed over the open cluster, that one is a lot closer, and that's a spherical puff coming off. It doesn't seem to have a bipolar nature to it like this one does. Maybe it's due to rotating stars, and maybe we're looking at the material coming off the poles here or off the equators of fast rotators, and that they're rotating around an axis like this perhaps, and spinning off a lot of their stuff this way when they do. Don't know. I mean, we know, yes, but I don't know about the dumbbell in particular. So,
may I add?
You may.
I'm sorry. The white dwarf there in the center, well, that is what's left of the red giant that sloughed its atmosphere off.
Which is this. This is the atmosphere of the red giant you're seeing here, guys.
Exactly.
Yeah. So that's how that works. Okay, so this is what's really cool about astronomy is that, we're learning so much in SkyTour LiveStream. You guys are so wonderful, and I think that it's really important to learn the basics too in astronomy, so that you understand where the rest of this conversations are going. And I like to be able to help you do that. So I hope you guys don't mind that I do that. I think you are okay with it. So this is the dumbbell, all right? It's a planetary nebula, and SkyTour LiveStream, we captured it with really quite detailed. Look at this. You can actually see almost the three-dimensional nature of this clouds here, and that's the way that the processing. The way I took the processing later, I was able to show it very differently.
Tell me that doesn't look like an apple core.
Yeah,
just
but
comment
it's
on that.
green
Rich,
and
commented on
rotten.
that
Look
too.
at it. Yeah.
Karen wants to know if they're searching for O3 on the moon.
Ozone?
Oh, I don't know. I thought you meant oxygen 3.
Oh, I see what you're saying. Okay, gotcha. Sorry. I took it literally. No, looking for. They wouldn't. We were not looking for doubly ionized oxygen on the moon. And I mean, there's a lot of minerals on the moon. Doubly ionized oxygen is a gas. And we're looking for, on the moon, we're looking at solids. All right. So, I mean, there's helium-3 that's bound up with other materials on the moon, and that would form part of a. That'd actually be a very important fuel in fusion reactors that we would use. But other than that, I don't believe that we're looking for oxygen-3 on the moon.
I had wondered that if she might have been thinking of helium-3.
Oh,
So I have heard of that.
yeah, as I have. And then this is the Ring Nebula that we're familiar with. That's another nebula.
What is this?
Oh, you see this.
This is the Ring Nebula in
Wow.
Lyra.
M57 Ring Nebula. It's another
Yep.
planetary.
Yep.
I have seen the Ring Nebula, but
And you can see its central star there.
it looks different in this picture.
Well, this is actually kind of almost an overexposure of it, believe it or not. But this is another planetary nebula. Again, the bluish color is reflective of the glow of the oxygen-3, the doubly ionized oxygen. We have an outer layer of hydrogen here, which is glowing in the hydrogen alpha, on the far outside edges. Pretty cool. And maybe
It looks brighter.
Yeah, it does.
Usually it's like more hazed out blue, like the one we were just looking at.
Oh yeah. And see what we're looking at here.
I want to say apple core. I can't think of the real
The
name.
dumbbell.
We were just talking about it.
Thanks,
I'm sorry.
Daryl. You're
Dumbbell.
such a pal.
No.
I
know.
I programmed her.
No, that's fine. But see,
This
I
is one of the easiest. The Ring is one of the easiest planetary nebulas to find in the sky. Also,
it is.
It's in the constellation Lyra.
Yep.
It's at the other end of the constellation from Vega, the bright star. There's 4 stars in a parallelogram, and the far end of the parallelogram from Vega, right in the middle between those 2 stars, is the Ring Nebula, and it looks gray to the eye, but it looks very much like that picture. Looks like a big smoke ring out in space.
It does. And I'm going to take you over. Unfortunately, we've got nothing but clouds right now, so I can't do it, but I can show you here. Okay, this is the constellation of Lyra. And what is Lyra? Lyra is the harp. Yep. And as we zoom in on Lyra, you'll see down here between Chiliac and Sulfat, okay, is the Ring Nebula. And it's literally about 2/3 of the way from Sulfat up toward Chiliac, right? And as we zoom in, you'll actually see that the ring is right there. Kabam.
There's a galaxy in the field of view too.
That's right. And here's the Ring Nebula. Okay. This is not quite the right colors for it, I don't believe, but it's pretty cool. So yeah, there you go. See, and that's where it's located. And that's to give you an idea. And I'm really sorry that we had to draw to a close the actual live portion of the fun tonight.
No, you still got a few hours in, so I think that's pretty
Yeah.
good.
Yeah.
And great skies earlier tonight.
Yeah, we did. But not anymore,
You can't
unfortunately.
help clouds.
Now here is another wonderful little planetary nebula. This is known as the Little Dumbbell. Okay, this is the little dumbbell, and it's a little guy that's actually again similarly colored for similar reasons. Okay, the oxygen is doubly ionized here with, again, little rims of the hydrogen around the outside. Isn't that cool? See, they have a similar morphology, but this one's also bipolar. Notice it looks like a mini dumbbell. It has a little tiny apple core with those little outer wings like we saw on the Dumbbell Nebula. Same kind of thing. And then we have supernovas, and this is the supernova remnant of the crab. Yeah, and these are all shot on SkyTour LiveStream here at the in our observatory. So there you see the Crab Nebula, and the central star there is this guy here, is that pulsar that we're always seeing. You know, and it moves. Oh gosh, was it 17 or 13 or 17 times per second? Do you remember, Daryl? I don't think it's that one. Wonder if it's that one.
Sorry, I was muted. Yeah, I think it's that one, and I thought it spun like 30 times a second.
Okay, I'll have to look it up. I don't remember the rotation rate.
There's a video probably on YouTube.
Oh yeah, you
where
can
they
watch it.
slowed it down, and you can actually see the thing flashing.
Yeah. It's very cool.
Speaking of the crab, Hubble, they released a new Hubble image just a few days ago of the Southern Crab Nebula. It is also a planetary nebula, and it is just an absolutely amazing picture. APOD had this up a few days ago, I believe. If you go look for Astrophoto of the Day, they had it up. It's in their archive. It is just a tremendous picture. You wouldn't believe this.
I'll have to check it out.
Called the Southern Crab Nebula.
I'll have to check it out. Is it in the Magellanic Cloud?
No, it's what is it in? I think they said it's down in Centaurus.
Okay. Very cool.
You know, that would be roughly down under Virgo, I guess, or somewhere in that part of the sky.
Well, it's not up here. We only have a few stars of Centaurus that are above our horizon.
Exactly.
Yep. Well,
that's
cool.
Why that's why I had to go to New Mexico to see Omega Centauri.
Yeah, that's right. Although I saw that Omega Centauri was actually above our horizon earlier tonight. Believe it or not.
Sure.
No.
Barely. It just breaks the southern horizon.
Yeah, I know. I'm trying to remember. Oh no! I think actually I had the ground turned off, and I thought it was the horizon, but it was actually something different. So when I turned the ground back on, it was hidden again. So that was my mistake. Here's another supernova remnant, and this one again shows you some hydrogen and oxygen, and there's other elements in here as well. This is the Veil Nebula, okay, that's in Cygnus. We'll see this again in the summer when it comes up. It'll be beautiful, and we see this. It's right in the middle of the rich Milky Way of Cygnus, and it's a remnant of this is only a small piece of an extremely large spherical, or round rather, exploding remnant that's coming at us and going in every direction out from the central progenitor, that is the star that caused it when it blew up. And it's really, really beautiful. And along this front, as it's expanding, it creates other opportunities for stars to form, because where it compresses stuff as it's moving through space, it compresses dust, and it starts the gravitational train moving, where everything starts to gravitate towards something. And if it pushes a little area over the limit, then it might get very knotty, and as in KNOTTY, okay, and start bunching up and forming something. And that might be what we see, for instance, right there, going on, perhaps. Maybe not, but we know that these objects will often generate new star formation with the way that they're expanding out into space. And this is going this way. Okay, basically roughly in the direction of the arrow, slightly to the left. So that's a pretty cool supernova remnant, the Veil Nebula in Cygnus. And this is the other side of the veil. This is the side of the veil that's actually looks like this. This is sort of surreal the way this looks, and I kind of made it that way on purpose when I processed it. But that's the other side of the veil. You know, and now, that was in Devil's Tower in Wyoming when I was out there.
Is that a satellite?
No, actually, that's an aircraft.
Oh.
That's just an airplane. You can see the blinks and you can see the blinking lights from the plane there. See, blink, 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 blink. Yeah, and by counting the number of blinks and knowing how the FAA requires 60 cycles, 60 flashes a minute, you can figure out the time of the exposure time that we took this with. Just kind of.
What direction were you facing there?
I'm facing kind of toward the west, from toward Devil's Tower.
I was wondering, you have a pretty good nod of nebulosity there, right below that airplane.
Oh yeah, you know what that is? That's the Lagoon Nebula.
That's what I thought.
Yep. And this is the Sagittarius star cloud, and actually, to see that, you can see the Sagittarius star cloud pretty bright there.
And that's the handle of the teapot. Those 4 stars on the lower left right now.
Yeah.
You scrolled up some, you can probably see the entire teapot. Yeah, right there. See, there's the handle at the upper left, the lid to the upper right, the spout to the lower right, the base of the pot at the lower left.
Oops.
See the teapot?
Yep.
No.
Oh, let me zoom in, Daryl.
Yeah.
You're talking here.
Okay, yeah, that's the spout of the teapot, I believe.
Right here.
No, that star to your right, to your upper left, to your left, bright star. Right there, that star, then down to the lower right. Right there, and then the star far down to the lower left of those 3 stars. I believe that is the spout of the teapot. Probably actually see it easier if you zoom back some.
Yeah, I'm actually, I'm wondering if maybe, I'm trying to see, I'm not sure that's actually correct, but because it sort of looked like might have been too big, but you're thinking that you're saying this was the teapot right here.
No, I'm not. Okay, and I probably was wrong about calling that spout thing. Can you back out a little more? Scroll up a little higher.
Yeah.
Okay, right there. Those 4 stars in that kind of what's the word I'm looking for? It's not a rhombus, but those 4 stars right there.
Trapezoidal.
That is trapezoid. Thank you. That is the handle of the teapot.
Yeah.
And now then, if you go straight over to the right from the bottom right-hand star in the handle, that next star you see, a little bit to the upper left of the end of the trail of that airplane, that is the top of the lid of the teapot. And then if you go almost straight down a little to the left from there, that is the inside corner of the spout. And farther closer toward, farther to the lower right, that's the tip of the spout.
Talk about here?
No, farther down.
On here?
Right there, that's the tip of the spout. And the bright star to its upper left, that's sort of like the inside corner, top corner of the spout.
Okay. Well, I see Sagittarius and recognize it in the sky with no problem, but when they get under a really starry sky, it
can be hard.
It's very hard sometimes to see what's going on.
Oh, I see it.
Okay. Well, moving right along.
Anyway, I'm sorry. I didn't mean to commandeer
No, we didn't. That's fine.
I like saying things like that.
Yeah.
So would that be an asterism or something?
Unofficially, it's an asterism.
Yep. It's the
I've said
Andromeda
before,
Galaxy.
The ancient Greeks saw a half man, half horse shooting a bow and arrow, and we see a teapot.
Yeah.
I'm sorry, Mark. Carry on.
Oh, no,
You
that's
should have
okay.
told me what the half man, half horse was. Shooting an arrow. Maybe I would have seen that.
Well, that's Sagittarius the Archer.
She knows. She says she wanted to see the pattern in the stars, but
Oh, you'd have to go to Stellarium for that.
yeah.
I don't see a half man, half horse shooting a bow and arrow.
Me either.
Well, I don't see anything.
Well, you see a galaxy here. This is part of the Andromeda Galaxy. This is our close-up shot, and you can see the dust inside this galaxy. Look at it. Can't miss that black dust. See? Beautiful. And I think we have a shot here of the galaxy from inside. This is our own. And you can see the black dust in our own galaxy.
I see North American Nebula there, just
Yeah,
left center.
right there, yep. That's the North America Nebula.
Yep.
And we have other pictures of that we took, in fact, with the, this is measure 13, I believe, which is the globular cluster in Hercules. This is measure 33, the galaxy in Triangulum. Okay, it's a beautiful SC galaxy.
Yeah.
And you can see various hydrogen-rich star-forming regions in this galaxy.
Exactly. That's a great big one up there toward the upper left.
Oh yeah, this is the biggest one in the galaxy, actually. Yeah.
Yeah.
Yep. So these are just beautiful. And I made a particular chore of mine to show this as a to show these H2 regions, as we call them, these hydrogen regions in this galaxy. Very important to show those, because whoops, what happened? Okay, we're back. So moving along, this is the Black Eye Galaxy. Actually may not be, sorry. That's not the Black Eye, that's a different one. That's a sunflower, I'm sorry. Sunflower Galaxy. I had to look at it. Alright. And as usual, sunflower, yeah.
Sunflower. M63?
Maybe, I'm not sure.
Doesn't matter. Carry on.
That one's
Okay.
pretty.
It is. Oh, and this is an Earth Impacts Effects program, which I did not expect to see there. This is the double cluster, which is a beautiful cluster in Perseus. It's a gorgeous cluster that shows two nearly identical clusters, rich with the same amount of members, roughly, with some beautiful red stars that are in them, or maybe superimposed on them. Because it's such a younger version of a cluster versus, you don't see too many stars that are various different types of stars within the same cluster. Let's see. That's the...
Bonnie wants to know how far Andromeda is.
Andromeda is 2 million light years away, and this is the Andromeda Galaxy that I was going to right there.
Wow.
This is our wide-angle shot of the Andromeda Galaxy that we took. Now, we took this with our 5-inch refractor mounted on the telescope, so you can actually see the two companion galaxies. Actually, I should try and show all of this because we can't really see all of it. We're not able to see all of it in this view here. Let's bring it down.
May I say something?
You're always able to say something.
I wanted to address Sean Hawkins in chat. Sean, I think why you want to build an observatory on top of your house, that is an extraordinarily bad idea. You will suffer vibration like you would not believe if you put an observatory on top of your house, unless it is solidly connected to the ground, like with steel and concrete. Every tiny little vibration in your house will make the scope jiggle so bad you won't be able to see anything.
Yeah, and you won't be able to take photos, Sean. And what's funny, Sean, is you're mentioning getting a pop-up ice tent. I gotta tell you, I went through that whole process as well, and the pop-up ice fishing tent was great as a portable observatory. I thought that would make a great thing because you could actually then you could say, well, I'll keep the wind off me, but you can't heat it. And the pop-up ice fishing tent is also small enough so that the heat from your body will heat it up enough so that if you have an opening that you have a telescope sticking out of, then the problem you'll have is that that opening is going to be flooding warm air out of it and ruining the views. I hate to say it, but unfortunately, the best use of the pop-up ice fishing tent is if you have an actual telescope sitting outside, and right next to it you set up the pop-up ice fishing tent, and you go inside and have a heater in there, because you can, as long as the telescope's not in there. Then you can stay nice and warm in the heat. And because I went through that, I was thinking of actually, before I decided to go this route that I've gone, where I'm doing all this remote telescope operation from inside the house, and the telescope is 50, 60 feet away outside on the front lawn in its observatory building. I basically was going to use the ice fishing tent idea to make a warm room, and I abandoned it only when I realized that I could do this from in the house, and that I'd have to have so much ancillary equipment out there with me to do this. It'd be crazy. But that's not, I'm not saying don't do it. I'm just saying keep in mind that there are some things that you have to think about with that might make you change your mind a bit. But if you have any questions about it, feel free to ask any of us. I'm happy to help you with whatever you want. See if I can offer you some advice.
Well, I'm sorry. I didn't mean to crow on Sean.
I don't think so.
I saw Ronald express a similar idea recently that he was wanting to put his telescope on top of his house, and it was over at ERRT, if I remember right, and I was lurking, so I didn't say anything. I couldn't say anything.
Sure.
But just extraordinarily bad idea.
Yeah, and Sean understands. He makes a note of it. He follows what we're saying, I believe. That's good, Sean. And making the pop-up tent your little warm area to keep the computer dry as well from dew makes a lot of sense. But keep in mind that your telescope is going to need a dew heater on it as well, or else the lens and or the corrector plate, if that's what you've got, I'm not sure what telescope you have, is going to dew up on a summer night, probably in 25 minutes. And then what we do and have done in the past is we would actually take a portable hairdryer and just blow off the corrector with heat. And that would actually, because the telescope would be sitting out in the open, that would actually not affect the images. Oh, yeah. D. Smith. He's funny. I used to sound. I would be so cold in there that people would shiver with me, and it doesn't make their experience a nice one. Now at least, see, I'm indoors. I can have the heat running, and I'm just totally cool in here now. And that's why this let's see, 4 hours 6 minutes. So, all right, that wouldn't happen on a winter night. Yeah, that's this guy.
You came pretty close.
Oh, only if it was.
Even in the coldest temperatures, you gave it your all.
Oh,
I appreciated it.
Oh, I love doing it. There's no doubt.
Mm-hmm.
Here's the Pleiades, a section of the Merope Nebula. You can see that beautiful combed look that Daryl likes and that everybody likes in the Pleiades. It's really pretty.
Oh, yeah.
Hot blue stars traveling through dust grains in space.
I didn't get it for a long time that I would see that, and I was trying to answer figure out how the dust got looking the way it does in the cluster, and not that it's really much of a better answer, but yeah, the I guess the cluster is actually passing through the dust cloud.
Yeah, that's true.
We just happen to see that. What's making the combed appearance still? I don't know, Mark. What would it be? Like magnetic fields or something?
Well, it's just the way the dust was deposited in the interstellar medium. You know, as it was, as other stars passed by it. I mean, I'm not even sure how close to the stars these dust grains are. But this is a reflection off of the dust grains. All right, reflection nebula. Actually, there's scattering involved too. You know, and scattering in our atmosphere. See, what happens is, you know, molecules in our atmosphere scatter blue light very effectively, which is why our sky is blue and the red is not scattered. That's why the sunsets are red. Well, here we're seeing blue reflection nebulae because blue is being scattered as well. You know, and evenly, you know, so that's kind of an interesting thing. So I mean, even with a white star, reflection nebula is blue.
Right.
So that gives you the idea. And you know, this is the this Maya. I think it's Maya, the Maya Nebula. This little tongue of nebula that sticks off. This is in the Pleiades. Okay, it's really just a beautiful sight. Again, all dust clouds. Now we talked about the North American Nebula. It's North America, not the North American. The North America Nebula. Okay, and this is the North American Nebula. This is the Mexico segment. Okay, this was one that we took a picture of. And look at that. I mean, that's just gorgeous detail down here in this part of the nebula. And again, taken with the 5-inch refractor on the back of the telescope.
That's nicely done.
It's beautiful. It just was such a nice photo. And when I saw how it was coming out, I was like, oh, I can't believe it. This is what it looks like, you know, from a distance. Okay, there's that Mexico segment right there. Florida. Okay, and this is, you know, this is the rest of the North American Nebula. Really pretty. Oh yeah.
Where's Canada?
Up here. That's up way up out of the shot up here. Yeah.
That's right up. That's right up next to Deneb in Cygnus.
That's right.
Head of the cross, tail of the swan.
Yep. This is the Omega Nebula, another summertime object. Which is really pretty. And this is the Rosette Nebula, and I'm gonna shrink it down to be able to. Why does it do that? Why did it do that? I don't want to do that. Okay, shrink it down. Alright, and now I bring this over here, and now you can actually see the rosette. So there's the rosette. This is actually, I couldn't take a picture of the entire rosette with either the 5-inch refractor or the telescope because it's so big. So I actually had to do 4 quadrants. I had to do this area up here. I had to do this area over here, this area over here, and then this area over here, and then put them together in Photoshop. And it's seamless. You can't tell where I put them together. I actually wrote some code to actually make the transitions even between them without changing the data. And it was able to recombine these all. Very pretty.
It is. So it's a mosaic.
Yes, it is. This is a mosaic that I shot.
This is NGC
2244.
64?
No, 2244, I think.
Yeah, in Monasteros, the unicorn.
Yep.
We looked at a while back.
Yep.
I have seen this exactly once in my life. It was on a large telescope with, it had a filter. I want to say it was a hydrogen beta filter, I forget, but you could actually make it out.
Very
it was
cool.
very dim and gray, not red like this, but
no.
You could actually see it.
Yep. And it had to be a 20-inch plus telescope.
I think it was that 13 I've looked through.
Oh, okay.
I want to say.
Maybe you're in a
It
dark
was,
sky.
It was that guy that built a scraggly old wooden telescope out of an old 13-inch Coulter.
Oh, okay.
Really junky-looking scope, but it worked really well. Uh,
Very cool. Well, I would say that my lights in here have shut off, so I'm still here.
Mark in the dark.
But my lights shut off. Yeah, and I will turn them back on. But there we are. So I did want to just mention that I want to thank you guys for coming out and hanging with me tonight. I had a great time, and I think you did too. But you will tell me for sure. And leave me a comment. Daryl, thank you so much for joining me. Amanda, I'm glad you finally made it over.
Thank you. Sorry for the lateness.
That's okay. And you're off doing things. I can't blame you for that.
thank you for having me.
Oh,
Sorry
of course.
if I was naughty earlier.
You weren't.
Maybe a little bit.
That's okay. It was all Amanda.
It always is.
See?
Everything's better with Amanda.
Aw, thank you.
Thank you for having me.
You're sweet.
Sure.
I had fun.
And chat had a lot of great questions.
They really
and-
did. I really enjoyed their questions tonight. Very, very
And some
well
of the
done.
questions, I'm like, I should have come up with this a year ago. I should have asked this like so long ago, and they make me think. I'll
Yeah.
read a question, and it just makes me think of like a million other things. It's like, ooh,
Yeah.
what about this and what about that?
That's
And
right.
so, and again, we wouldn't be doing this if it wasn't for chat. Well, Mark probably would. He loves it so,
I
but,
do, but that's
you
okay.
guys make it worth it.
Yeah. I wouldn't be doing this with Amanda if it wasn't for chat, because she likes it. She likes to chat a lot.
I do like to chat
She
a lot.
loves talking to people. She's very social. We're gonna find out just how social when she goes to Pine Bush. That's right. She's going to Pine Bush to our festival.
Oh my god, and technically, since it's after midnight, it's Thursday. 2 weeks.
You're right. You're not
2
far away.
weeks today. Oh my gosh.
That's it.
Freak out time.
Well, folks, on that note, I just want to thank you for coming out and joining us tonight on SkyTour LiveStream. Thank you for taking the time to ask these marvelous questions. You guys are very, very cool about doing that, and I am very happy to be part of that world with you. So I want to thank you on behalf of Amanda, too, who joins us, and on behalf of Daryl. Thank you guys for coming out, and we will see you on the next SkyTour live stream. Good night, everybody.
Night, everybody.